spend 10 minutes, at least the next 10 minutes, looking at the core group questions and kind of just being very clear that I'm going to do a full run of these questions from start to finish. This one, I do remember that triple integral. Well, what happens is this one doesn't have a z, this one doesn't have a z. Right? This is the only one with the z. For the pairs VH and VH below, V is a vector space of R, H is a vector space of V. Select the pairs where H is a subspace of V. We want to select one where it's a polynomial and it has a zero vector. This one, weird. This one, matrix. So just a linear transformation of a matrix. Holds linear transitivity. Integrable functions, same as the integrable function, with a point at 0. And this looks like an eigenspace, right? So an eigenspace is still a vector space. Still works. This one, we use the subspace theorem test. Zero vector does exist. Does closure under addition exist? If A is equals to minus A and B is equals to minus B, then A plus B transformed should equals minus A minus B, which is minus of A plus B, so which is here and here, right? Or minus A plus minus B is the same as minus A plus B. Or this is the same as A t plus B t. Closure and addition works. Okay. This one, I think we start here. We start with z is 0. We find some points. A is either 1 or 2. Then at x is 1, y is 0, right? Or x is 0, y is minus 2. Use that to find the points that e is equals to 2, and also that because this is a curve up, the thing that's associated with like that p needs to equals 2 as well. What's a? Yeah, that's what I mean. A. The p is, we have to, how do you get p? Is p larger or equals to 1? Larger than 0. Yes. Here. It's a positive number, right? Because it caves up in a y to z plane. The problem here is if we're setting up something, this needs to be some z of y plane or some y of z plane. And then if we're going to talk, we have to talk sideways, shit like that. B is equals to 2 right here, once again, because it concaves. But we have to know if r is less than or equals to 0. So if r is equals to some bz, so in the z to y direction, if we treat this as z and y, then these become negative numbers and it's going down. So r, which is associated to s, should also equal 0, less than 0. Here, it opens in the negative direction. So z is 0, e equals 2, a equals 2, p equals 2. Then we have that 2x squared minus y plus rz. We also know that at this point, with x is 0 and y is 2 and x is 0, this is equals to 2. We also know that when x is minus 1, b is 2, a is 2, p is 2, x is minus 1. Set everything in here so we can find an equation for r and z. And that's how we can find rz as well. This look in where? In the left picture shows the cross section with the plane y is b. So I have to put y is b right down. Z is sum f x y equals b. So here's z f x b. Z a y. Parallel to the tangent line, we have to use the df dx 0 1. Right? And d 0 df dy 1. Oh shit. Okay, 1 for x in the x component, in the and y in the y component. I don't like that it's bobbing. One sec. Let me see if I can tighten this. That's pretty sick. Okay. Yeah. This direction. So 1 0 df dx 0 1 df dx. Parallel to the tangent curve of the cross in the left picture. So it needs to follow this. And we can get that using the tangent curve right here, 1 0, and that tangent curve. Perpendicular is the negative reciprocal. So it's minus 1 over 2.2 of that. And then for this one, you should remember to use point normal form and a cross product. Yeah, compute the cross product. Make sure these numbers are more than 10. Yeah, larger than 1. And then you've got some given points now. These are the x zeros and stuff. And then we also are given some new a's. And what's that a? Where's the A? Oh, is that the change? Saying that's the change. So this is the alpha. That's the change. That's the alpha. And these are the numbers that we're given as well. So partial derivative with respect to x at AB already. Partial derivative with respect to y at AB. This one is a compute question. Question 5. I think we turn shit off when we're trying to compare. If the vectors line up in the plane, then yes. If they don't span, they don't span the third dimension. Yeah. So you turn these three on, and then you see if they do come out or do they line up. If they line up, they're collinear, which means they are not linearly independent. They could span R2, but could not be linearly independent. They can't span, but they could be linearly independent. We're doing a proof here. For every x in R, we have the linear combination for some for some value of these scalars that exists in the real number system. They think these are not a spanning set, so there exists a vector that's a non-zero vector such that you cannot combine these bad boys to create this vector, which is in our your R set. So the logic behind this question is, hey, if it does really span R2, I could create any vector. But actually, there does exist a vector in R2 that I couldn't create with the set. If they think these are linearly independent, we have this equation, scalar, or the linear combinations, add to the zero vector only when all of these guys equal 0. And if they think this is linearly independent, then we have a vector w is equal to 0 vector, but then these are all not equals to 0, or for some that's not equals to 0. Then that means that, hey, you could create one of the other twos. Now they're saying, hey, could I have a basis? I'm saying, nope, neither this nor this could be basis, because this is way too big and this is way too big to be a linearly independent set, and this is way too small to be a spanning set. The rows don't matter. The rows don't signify dependence. It just tells you that it doesn't span the whole codomain. Maybe it spans R2, but these are linearly independent. It's okay. I'll run Don't worry. So okay. These two are linearly independent vectors. These two are linearly dependent. It is a linearly dependent set because they have one or more leading columns, for sure. And it is linearly independent because A has more columns than rows. Yes, because the rows signify the space. We're living in R3, but we have 4 vectors. So no matter if I even see this, I know, hey, this is going to be A is going to be a linearly independent set. Select all that have a statement and a correct reason. This does not span P2 because it has one or more 0 rows. Wait, what? P2 is 3. Yeah, okay. P2 is 3. Because it has a 0 row here, we know it won't be able to go to P2. It could be a constant or it could be a linear. So up to 1 power. There's no third vector in here. There's no third polynomial in here. That makes it so that it happens. Then I can see we can use P1, P2, and E2 because these are the first sightings of the linearly independent rows. Columns. This times the 0 vector, anything times the 0 vector, any linear transformation times 0 vector should have the 0 vector. This one can't create this one. You just couldn't. This one is created off of this one and this one and this one, and you can add to get that. This one we've already computed. This one we've already computed. This one, because now we have E3, we could do this. Or sorry, this minus this, which would be what? A whole of a lot less. This number. Yep. This question, ooh, this was like a pain in the ass. Select all true statements for transformation of V1 is equals to image W1. Transformation V2 is equals to the image W. That one can't go to its domain again. That one becomes its 8 times its image. So it's linear transformation. So it works. This one, you can't transform the vector spaces. Can't transform the vector spaces. This is a proof of the linear transformation, which is fine, right? Because they still say, hey, the transformation here, the transformation of this quantity is equals to the separate transformations. This, once again, is, oh yeah, this is wrong. This is the same as this. Because alpha is a constant in R. we can use the thing that we've learned. So we're going to use linear solve to find the first few questions. And then the second one is we will have some A, P, Q. Basically, right? We could have some vector A, some vector P, some vector Q. And we can just solve it that way. We have 1, 0. We have, where's A? A0 minus 1. B is minus 4, 3. And transform went to minus 3, 4. And 1, 0. And so we could just force that into the equation. This question wait, let me see if I can remember the set. Sorry, what I meant was you start with this, right? And then you'd go like cosine, cotangent. And this is like cosec. Yeah. And then you go like cot. You go like hyperbolic secant, and this one you go like hyperbolic cosecant. But we will use the substitution, and then we will make sure we get the right substitution for 1 over sine squared t. And, well, they said that the integral is cotangent, right? Which is the same thing as, instead of sine over cosine, it's minus cosine over sine. So it's everything reversed, which is basically minus cosine t over 4 sine t. And since we know that x was our substitution for 4 sine t, we know that sine t is x on 4. And so sine t is basically the opposite over the hypotenuse. So we start with the equation for x from the initial x substitution, and we try to find the trig value of the trig in terms of x. Then you place them in the correct spot. You know x is there, you know 4 is the hypotenuse, so you know the number at the bottom, that number, that should be square root 16 minus x squared. And it says write in the box. Do we write in the box or no? Let's use Moodle. Let's see our Moodle. Oh, okay. So they just want me to find the 4. They want me to find the integer. They want me to find the integer. 2 of these are non-constant functions, and one of this is equals to x. X is 4 sine t. The third remaining side is a constant integer. Find the integer? Okay, cool. Next equation. This one, we have to use that substitution, and we have to remember that dx is going to be like 6e to the 6x dx. Yep. Use the integral. Then we can use par frac. If we use par frac, we're able to use this. Convert par frac. This is probably me without using par frac ever. And then we can integrate the par frac. This is in one of my my integration series. Where's the start of the exam season? This one. Yeah, just par frac everything, eh? And then make sure that we can use our log rules. We factor out 1 over 54. We basically put a 3 on to basically you scale up the 3 so you can right? You multiply everything by 3 here. Right? You're gonna multiply everything by on the top by 3 and on the bottom by 3, so it's 3 over 54. Then you're gonna factor out 1 over 54, and then you're gonna combine it, and then you're gonna substitute u back in. This equation that looks not separable. But it is a first order. That's it. It does not look exact at all. It just looks first order to me. And then what did we do? We had to do y is x of vx for that. So substitute everything as x vx. dy dx is equals to that's basically just us deriving the formula, right? Oh, we start with that, then we differentiate both sides. Then we get dy is equals to d dx of x plus v. Then we use the product rule. After we have the product rule, we also know that dy dx is equals to dy dx is equals to that. Okay, just don't care about the dy dx anymore. It's the same thing as the d dx of xv. Yeah. So we're just going forward motion. It is first order because you've got dv over dx. It is separable because you would multiply dx to the right hand side and divide v3 plus v to the 3 plus 3 to the left hand side. And then it would tell you, hey, you'd want to basically par frac it into these three things. So once again, we could par frac it using Maple's par frac function. And then what do? Oh, we're going to integrate. After we have the par fraction, we're going to integrate the two different things by using a u substitution, and just directly integrating 1 over v is ln v, and the u substitution is you pull out the half, right? Because you're, then you integrate, and then you put v back in. But once again, we could use Maple to find ln v minus half ln v squared plus 1. Absolute value as well, eh? I don't think we need absolute value. Yeah, we don't need absolute value. Let f be this odd differential function. We have to, okay, they just made it so they can fuck around with us. But you start with that derivative, then you have some function of g, which is the kind of the chain rule part. Same with h, that is the chain rule part for y. So you're differentiating the chain rule for y. And then f of x is equals to 2x squared. So you've got this big ass function f of x squared plus y squared plus 3y squared. You're going to do f of x is x squared plus 3x squared, which is like, what, 5x squared? 5x squared is equals to minus 2x. We're going to substitute a t is equal to 5 of whatever that is. Then we're going to try to find x squared is some other t of 5. Then we know that ft is basically, then we isolate f. Yeah, we isolate f. Or f needs to be isolated somehow. when we create those substitutions. And so we know f of t is equals to minus 2t on 5. Then we're going to notice that the f function is just dividing whatever the input was given by minus 2.5. So it just scales down 0.4. So the whole bigger function is basically, when we take away f of t, it's going to be minus 2.5 of whatever the input we had. This is we're going to divide. Firstly, we're going to divide so that we can get y prime plus some function of x, y is equals to a full function of x. So, fuck me. Why the hell is it just like falling off? Okay, divide. We get the integrating factor, which is going to be, one sec. Get the integrating factor is going to be x cubed over square root of x squared plus 4. And then x squared plus 4, we're going to whip out our shit. And then, because we set the constant integration to 0, we don't ask you to type the expression for h. We have the output for this. Yeah. What are we going to do? We're going to integrate the... Oh, yeah, we're going to use our tan substitution that we talked about. Then we'll get to this point. Sorry, we'll get to this point. 16 tan cubed sec squared. That's where we could integrate and simplify the expression. And then substitute 0 into the expression. 0 for x, yeah. So we can get basically our constant of integration. This looks exactly like an exact function. Yep. And we need to find the normal. So, oh, we've done this question. This is a 2025 question. Find the normal, compute, deduce that h is equals to, well, the partial integral, and then you find the partial integral using the other way. I don't think you should use maple. 3 sine 3 is equals to minus minus cosine 3y. Minus cosine 3y. Exponential. Oh fuck! Remember that it's an integrating factor. Exponential of minus 16 on 3. Remember that it's an integrating factor. Here, h of 0 is equals to 2 times minus 8. Yeah, I don't know why the fuck they did root 4. Because root 4 would give you 2. Minus 16 on 3. But you have to remember it's e to the whatever. Next question. Move on. 3 sine 3y. Oh, okay, fine. Whatever. You integrate cosine, right? Yeah, okay. This is using this initial equation right away. You want to use m1 is equals to m minus m2 on v1 as a function of f. Yeah. And then you split up the functions, and then you get yourself that f of t function, which is sum m minus a of gt. Because we know that gt is m2 over v2, so. So m2 is equals to g2 v2, which is the same as minus 12,500 over 2,500, which gives you an alpha a of 5. That c is always 0. That ugmt, well, you're trying to find the derivative using f of t minus g of t, and you're trying to simplify. So it looks kind of ugly, but you'd be doing like m 2500 t minus 5 gt on t, or plus how many gt on t's. Here you go. You have that. dg of t is equal to m over 2500 t minus 6 gt on t. And then you would use the initial value problem, or you would just name the method, which is this is a linear, yeah, it's a linear first order ordinary differential equation. So you'd find the integrating factor, which is like e to the 6t. What's the concentration of R2? This is the limit of the whole equation, which is m over 15,000. And that is the same because the rate of change is proportional, and C is the long-term concentration. So after the long term, both reservoirs will basically have the same concentration because they share the same mass after infinite time of mixing, and there's no outflow, and the mass is stays conservated. The mass stays protected inside after a long time. We would want to remember that what that is, but I don't think we would. M is equals to 15,000 C. The mass is equals to the volume times the concentration. Okay, volume times concentration. Volume over concentration. Volume over concentration. This plot shows two vectors. We're trying to find some eigenvalues and eigenvectors. Try to make sure we can see if the vectors just line up. If they line up and they point towards a good direction, then they cover each other. Then we get our marks. This question has the first three values, V1, V2, the first few column spaces, worth noticing. And so what do we do? What do we do with this? We create a matrix of the first three rows. And then yeah, so we take their matrix, but then we take away the B and the A rows. And then we find that the A times our V1 is equals to minus 1 minus 1 minus, sorry, is equals to 8, 8 minus 16. So we see if there's basically one lambda that could use it. Right? So in our case, it's, hey, it's minus 8. So minus 8 works. And then we compute the next one. And we see that 40 minus 43 and minus 25 as the output of B2 just doesn't work. We'll do the third one. Well, the third one also doesn't work. The fourth one doesn't work. And then the fifth one is going to be minus 16, 32, 16, which shows us, hey, well, that means that we could have an eigenvalue of minus 16 here, which is possibly true. So we choose B1 and B5. And then he said we're given that vector, and then we're going to find the lambda. Well, the first three values of the lambda say that it's going to kind of compute to minus 24. So the best guess for the eigenvector, the eigenvalue would be minus 24. We have a plane and a line, and we're trying to find whether or not we could have a correct diagonalization. And so the correct diagonalization is if you have the right eigenvalues in the right spot, and always for the invertible matrix, much more important, is the independent eigenvector, regardless of multiplicity, where it needs to be. For what I'm saying, this means that those three guys all have to be linearly independent. This second choice here, 5, minus 5, and 16, we see if we can make it, and so we're trying to spot if it could be made. we would try to kind of circle that matrix up, try to do a linear solve, see if it becomes something possible, and then what we'll do is we'll look at the number of points. There's 3 points. So I'm assuming the 3 points work. This third one is nice. You're basically, it's the 3 eigenvectors and the 3 eigenvalues kind of mixed up, which is fine. We have a matrix output, and we see R1 having 1 independent eigenvector. Prove that it's not diagonalable. So, prove. Rank R1 is 1. So the rank nullity theorem gives nullity of R1 is 1, since the vector minus 2 minus 1, sorry, let's do the vector 4, 2 is minus twice of the first vector, and the characteristic polynomial equation has a eigenvalue. So using the factor determinant R, we see that the eigenvalue is minus 6 with the multiplicity 2. And so, since we have an n-by-n matrix and we need 2 linearly independent vectors to be a diagonalizable matrix, C is not, because C only has 1 independent eigenvector. Let's turn this bullshit off. That's a good one. Cold, 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 cold feet. Theorem 1, if an n-by-n matrix has n distinct eigenvalues, then it is a linearly independent, then it has n linearly independent vectors. If an n-by-n matrix has n linearly independent eigenvectors, then there exists an invertible matrix M and diagonal matrix such that M is, I think we need a notebook. Or not notebook, but at least a notion with our core group questions. Core Q21. The characteristic polynomial lambda plus 2 squared. So minus 6 is the only eigenvalue and has an algebraic multiplicity of 2. Since R1 is equals to R1 equals C plus 6, 1 has a rank 1. The rank nullity theorem gives nullity is 1, therefore the eigenspace has dimension 1 and contains only 1 linear independent eigenvector. But a 2x2 matrix requires 2 linearly independent vectors, so C is not diagonalizable. And then we said find 2 diagonalizable matrices. Oh, this is a hard question. this diagonalizable one, we have to set the equation as a plus b is equals to our c. And we want to modify a so that b only has a 0 entry on the bottom right. So we start with c is that, and then we choose a to be something so that we choose a to be a diagonalizable matrix, right? But that diagonalizable matrix has to take away from c so that we can get b is another diagonalizable matrix, or at least b has the 0 entry on the bottom right. Right? So that it is kind of the other way diagonalizable. I think that's what they mean. It's like, instead of the upper would a matrix be diagonalizable if it has an 0 triangular corner on the right? It's okay. Just make sure that we have that. We have a plus b is equals to c, then b is equal to c minus some a, and we have to choose a so that b is equals to we have to choose both a and b correctly, a being a diagonalizable matrix and c being a very, very nice matrix. We're going to substitute p so that we'll just have a big value for p minus some lambda, and then we're trying to find a number to factorize. Understand the AC method to factorize in quadratic formula. So we basically want to factorize and choose correct lambdas. So we want to choose the lambda based off of the c that we have, basically. Is that what they're saying? Choose the lambda off of the c that we have. This is basically our first thing that we gotta kind of do for today. We have a c is what? C is 8. Sorry. C is minus 8 minus 1, 4 minus 1. Choose sum a plus b equals c, and a, b are diagonalizable. Right. Choose a to be something that when I subtract by this, so I don't care what that is, I don't care what this is, I want this to be minus 4. So c minus a gives minus 8, 4, Why is it getting really, really cold? It's still warm in there. 4 minus 1 minus 4 minus a 0, 0 minus 4 equals minus 8 minus a 4 minus 1 and 0. Then let's find determinant b, right? We want to find that b minus this to satisfy equation. Determinant of minus, oh wait, also let minus 8 minus a equals p. So p minus lambda 4 minus 1 0 minus lambda equals the 0 vector, which is equals to, sorry, not equals 0 vector, 0, which is equals to this minus this, right? P minus lambda times 0 minus lambda minus minus 4 equals 0. P minus lambda minus lambda plus 4 equals 0. Choose lambda equals 4 times 1. Choose lambda equals 4 and lambda equals 1. Then four minus lambda 1 minus lambda plus 4 equals 0. 4 minus lambda minus 4 lambda minus lambda plus lambda squared plus 4 equals 0. Lambda squared minus 5 lambda plus 16 equals 0. Sorry. Wrong. What is with me and chips falling off the fucking table? This is the wrong approach. I should be doing this. Yeah. Choose lambda since p equals -8 minus a is 5, a equals -13, which shows that a then b -8 plus 13 is 5. -4, -1 minus 0 is -1. 4 minus 0 is 4, and this is 0. Okay. They are studying some physical object, and are these possible eigenvectors of D? Most definitely, because D is a diagonal matrix, so any kind of multiple of the eigenvector space of the bases are good. Yep. A is equals to that. The image of A should give us a vector in R3, which is good. And the columns of A are linearly independent because, well, when you find out, fuck around, you find out, then you'll know. For V20, he denotes an eigenvector of A with length 1 with the corresponding value eigenvalue 1. We want to find a valid choice for V20. Firstly, we want to use, there's going to be a bunch of equations with respect to the x on the bottom. But yes, V20 means lambda is 20, which is that vector. And okay, so find the unit vector of the eigenvector that's associated with the lambda is equals to 20. Is that what they're saying? V lambda to denote an eigenvector with length 1. Okay, so find the unit vector with lambda is equals to 20. And then they also want to consider that we're using maple output here. This one. Matrix multiply, and then we don't need to do the inverse b, we just need to set a y, multiply that y, and we get those values, which are the intermediary. I just named it as something. What gives nullity not equals to 0? Well, a 0. Yeah. And that crushes it. Crushes any vector in E3, which gives us to the 0 vector. Question 23 is the integral test. The limit as n to infinity of 2 to infinity of that integral. U substitution for ln x, then x is e to the u. So we're going to do e to the 3 of the whatever u and e to the whatever u times u. It's not really the hardest part, whatever. Because this is from x from 2 to n. If u is ln x, sorry, if u is ln x, u is equals to ln 2, right? Because we have to evaluate from ln 2 to infinity now. So that's by the integral test. And the series does, well, log k is small as shit. So log k, let's say, is less than a fifth. Yeah. So you multiply log k by a fifth. And that motherfucker still diverges. Because that motherfucker just gets so infinitesimally small on the denominator that it will diverge. Wait, sorry. I did not mean diverge. Oh, fuck. Oh, this one. Question 2025 question. F1 is 0, positive, negative, positive, negative. I know that, and I'm going to use R6 evaluated at x minus a, which is 0.5 minus 0.3 to the 6, and I have a6 is minus 6.8. Once again, absolute value is important. Oh, this is a cool ass question. 4k plus 1, k squared. If you expand the k out, you see that 4k on k squared, I mean, it should look like 4k over k squared, and then you get 4 over k, which is larger than 1 over k. But it still diverges. Yeah. 6 to the k times k plus 4 factorial. If we evaluate it using the ratio test, yeah, we see that's larger than 2. It should diverge. But if we do it correctly, what do we see? No, it's larger than 1. Because you have k to the, you have k squared times k, so it's like a very big, actually, I don't know. But you scale it up 6 times, okay, whatever. C, kth term test for the interval of divergence. K plus 2, you're expanding that. And you have to notice that k plus 2 is less than k plus 3, which if you have k plus 3, you cancel out the top, and then the top becomes like k plus 3 over something. So it'll be 1 over k. So this is less than 1 over k strictly, so it will converge. It says comparison with the p series, but it doesn't matter. B, ratio test, and P, kth term test. Alternating series, k plus 8 ln k plus 3 diverges by the kth term test. But you know ln k plus 3 is going to be a cool number. Ooh, that's a hard one. The fuck? Well, we do k to the half on the top, right? And we know that k to the ln k is always stronger to k to the half. What's p? P is diverges by kth term test. So we're finding the limit of that, and that's not equals to 0. This might be a little bit hard. Yeah, see this one. Okay, so we see an alternating series. We should look at Leibniz's test. And we want to test for absolute convergence. So we look at the limit of the power series with the positive. And if it does converge, then it will absolutely converge. Then we know that k is half on the bottom, so it will diverge. Okay, so if it diverges, it's not going to absolutely converge. Then it could conditionally converge if the condition is that the next term is lesser than or equals to something. But we see that it's decreasing. Nah, it's going to diverge. Are you saying this is hard? Oh, this is the method here. 4k, basically 4k over k squared, which is larger than 1 over k. This is basically larger than 1. This is smaller than, it's k to the 1.5, which means it has a fatter base. So the power series of k to the 1.5 will converge. That has a 0.7 ratio. And this bottom one, just look at it. Well, it's k times ln k over k 1 squared. So that doesn't go to 0 by any means. Is that what they mean? Oh, okay. Divide it. Basically k to the half times ln k, and it's k to the half is k to the half times ln k is basically like k to the 1/3, no? It's not a walk in the park to love each other. I'm still into you. I should be on the other path. I'm into you. I'm into you. Yes. volumes of a revolution, finding lower bound and upper bound, rounding up and down. Oh, this looks like a cool question. What's this one? Using integration techniques, sine a plus b is equal to sine a cos b plus cos a sine b. Sine cos cosine. What cosine is? Cos a plus b is equal to cos a cos b minus sine a sine b. But sine a plus b is equal to sine a cos b plus cos b sine a. Cos a sine b. Sine a cos b cos a sine b. So it's just ab, 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 but sine cos cosine. And then you split it out. The tangent cubed and secant squared is using a u substitution on the odd one. Is that right? Okay. Compute the average in the interval 1 over b minus a of, what's b minus a? That one, which is 2 pi, is that the interval? 2 pi. And the value's there. Okay. Okay. So there exists a C, its min value theorem for integrals. If f is continuous on AB, there is a C in AB such that there's a C on AB such that the integral of f of t from a to b is equal to fc times b minus a, which is why we divide both sides. We have that. Both are continuous. Both of their limits equals to 0, so they're also continuous. And by there does exist. Let's go to calculus notes for that. So it just says since f is continuous on AB and differential on AB, they're both continuous, and the limits of their integrals all evaluate to 0 at their endpoints. Discrete random variables. Continuous random variables. We want to solve alpha. Why did I do KT? Nah, it's okay. It's basically solve the integral and find the alpha, or find the value of alpha such that it evaluates to 1. Solve k times the integral from 4 to 7 equals to 1 for k. and the expected value is equals to x times alpha. Yeah, x times alpha, or x times f of x. In which we know alpha is that, so we have to use our value of alpha to solve. Are we almost done? I hope we'll be able to get this probability question. This is like a plus P1, P2 type of game. Yeah. There's a fucking whatever. There's a strategy. So 3 over 40 plus P1, basically. And the last one is... Let's see. I'm trying to route learn right now. I spent enough time trying to learn it. So see if I can route learn it. 2 over 15. Where's 2 over 15 from? Okay, 3 over 40 plus 2 over 24. That I know. Then if the game is won, so given that the game is won is the probability of winning the game, and the probability that the selector turned up red was 3 over 40, which is a win for us, right? Which is 1 over 2 times 3 over 20, which is a win for us. That's over the probability that we've actually won. So we want to find the probability that it was red, given that we won. Given that at least one of the colored die turn up win, what's the probability that the player did not win? So a lose, it's 1 minus the probability of a loose dice. Sorry, at least one win dice is the same as the probability of P of all lose dice, which is 7 over 24. That's the probability of at least one win. So we have to draw out red and blue. So it doesn't matter red or blue, right? Because all three were thrown, we want to see the probability where player's choice die was different from the win die, either red or blue. So if both win, player is guaranteed to win. If either red or blue wins, player could win or lose, but if both red and blue didn't win, player guaranteed lose. Yeah, so it didn't matter which it didn't matter which selector die. Let's go to this question. Do we have to create something big like this? It's not a walk in the park to love each other. So I had to create a red, blue, red win, red lose, blue win, blue lose, and blue win, blue lose, red win, red lose, and then we have to find the probability that we lost given that we had a winning dice. So the probability of having at least a winning dice is the probability of that's gonna be the hardest part. We have to what? Find the probability that a player's dice had at least a win or a lose. Right? Yeah. So that's the bottom. We find the bottom first. Which is it? But why we only did one branch? Okay. So we would combine red and blue. And then we just look at win or lose. Right? Usually we half it up, but then we just do a full. So we do one, red and blue. That there's 30% chance of red winning and red losing, and 30 chance, whatever chance of red winning and blue losing. So instead of halving it and multiplying by 2, we just did it once. But we want to find the probability of at least one win, which is 1 minus the probability of us losing out of the red. So lose is 17 on 20, and blue lose is 10 on 12. Usually that'd be divided by 2, but because we have 2, we're just gonna cancel that out. So we have that. Then a probability of a player winning. A player losing based off of at least a win or a loss would only be those two outcomes. Okay. Half of blue win, red loss, and half of red loss, blue win. So the hardest question would be, C part. Probability did not win given at least one die turned up. Win. So the die that turned up win, we have to create a branch where it's red and blue. Both win or lose. Red win. Red lose. Blue win. Blue lose. Blue win. Blue lose. So combined, so we don't need to count twice. It would be 1 minus probability that both red and blue lose equals our probability of at least scenarios where we lose, and this happens. P die is red, and we lose on red and win on blue. Or P die is blue, and we lose on red, on blue, and win on red. These conditions match. And that way we could find a probability. Last question. This is the first question of the 2025 paper. But they're doing mathematics. He loves probability. That follows that normal distribution. Do we have an answer for probability here? Or at least a question that we've done. Oh, who the fuck is that guy? David Lade, motherfucker. What the hell? If I could. If I could. Wait, Christine texted. Where's my phone? Where's my phone? Oh. On the ground.
stayed calm and had a proper look at the wound and didn't think we'd hit a major artery.
we can do core group and like these couple again. Go through the routes again. That'd be pretty nice. Okay. Wait, I need to get a monster to knock down.
Kill himself, but he couldn't kill himself. Oh, I think he was just end of the anime. End of the anime.
Locked in. It's 5:30. Should get it done. 2. Subspace theorem. Span looks good. This one looks good. This one looks good. This one looks good. This one looks good. Oh my god, I'm goated. What the hell? Okay. We start with the Z is 0. For P of XA minus Y equals E. And notice when Y0, X is minus 4. And notice y is equals to pxa, right? And for this, slopes up. So a is equals to 2. P is positive. P is positive. That's all I need to know. That's number 1. We also need to know that what's P? Sorry. We know y0, P is something, and X is minus 4 squared. Where's was that? X is 0 and y is minus 4. X 0. Y is minus 4. Yeah. So uh, 0 minus 4 equals E. Therefore, E equals 4. What we're going to do is we're going to wait until we can kind of fill in every single question first. Right. Then we're going to look at this question. So we're going to look at X is 1. Right? Yeah. Look at X is 1. We have E is 4, 0. A is 2. What else do we need? We need to find B somehow. Y, Z plane. Right. X is 1. P is non-zero squared. What is Y? Y is 0. Z is like 5 point something. Right? Okay. P. What's P equals? P is larger than 0. P times 1 to the A minus Y plus RZ equals E. Right? Sorry, equals 4. Equals E. 1P minus Y plus ZR squared equals E. E equals 4. Is that right? If I had, oh no, that looks like 1.75 for X and 0 for Y. Would I also have 1.75 squared times some P to find P? I could. 1.5, sorry. Okay. X is 1, P is that. Y is equals to ZR squared. And when we look at this value and we put Y and Z there, it's actually going like down this way, right? So B equals 1. R is less than 0. And when we're looking at the slope, we see this one at 5.5, and we see this at like this is like a little bit over 2. So the slope of this is 2 here, 5 here. So change in y over change in x. A change in y over change in z is 2 on 5. So it's less than 1 as well. 3, 2, 1. Fuck. Sorry. Let's see if this is right. Right. P has to be larger than 0, right? R has to be smaller than 0, no? R is larger than 0. Sorry, R is larger than 0. Is it? No. Why I think R is smaller than 0. R is the slope. How could I find R so that here is wrong? Why? Let's think. Plane for the Y to Z plane. Okay, does that mean we might want to find this? Y some... So 4 is correct, right? 4 is right. Would it always be E all around all the time? Or is it only at that point? No, it'd be E all the time. P, I should find Y is equals to PX squared. Or plus P at 0 minus 4 equals E. So E equals 4. So that is the intercept, no? Okay. Then P then 4 is equals to P 1 squared minus, let's say, y is equals to 0 plus r z 1, and z would equals to 5 on 5.75. How would you solve? Wow, this is very confusing. How would I, hello? Hello, hello? Yo, how would I consistently solve this? I keep making mistakes on this. I know we'll start with like z equals 0, which cancels out the z, which gives me some isolated kind of equation with pxa minus y is e, right? And so I also noticed that uh, y is equals to minus 4 and x is equals to 0, which gives me a value of e equals to 4 at z is 0, y is minus 4, and x is 0. Is that e going to be there continually? And then how do I use that to kind of find the rest? I also know that because it is a upward parabola in the equation that y is equals to some pxa, I also know that that means that a is going to be 2 and p is going to be a positive number, right? Because it's going to slope up. How do I continue to find the next one? Like, how do I find b, r, consistently? I always kind of make a mistake here and there. Can't be fucking up these questions like this. Come on. Honestly, I don't know why I keep making those type of mistakes. It's like I don't really understand the question at all. So I need to find p as well, right? Could I have found p? So the goal would be to find p next. Which is z equals 0 for px squared minus y is equals to e, and also x y is 0. So Oh, okay, thank you. P is 16 over 9. Then using P is that. Then I get an equation for B is 1. If B is 2, the equation would contain Z squared. Thus we have 0 and 6. R is 3. R is a third. So then we carry into y is equals to, okay. So you're saying that we always carry the 4, right? Okay, we're gonna restart the question and see if we can do it again. Because we don't want that shit to happen. This is a good set of notes. Every set of notes I'm gonna use. Okay. Okay, this is a surface. We're gonna start over. We're going to start with Z is 0. And we see that when Z is 0, I need something to like fix my. When Z is 0, X is 0, Y is 3. Right? And then we have P 0A plus 3 plus R 0B is equals to E. So this is equals to 3. Then also X equals 1.5, Y equals 0, which is 1.5 to the 1p, right? Slope down. Straight. Equals 3. Oh no. Set this equation px1 plus, sorry, yeah, plus y equals 3. Y equals 3 minus px. Basically. Then y equals 0. 3 minus 1.5x. Sorry. Minus p 1.5p 1.5p equals 3. P equals 2. So equation is y minus 3 minus 2x for graph 1. P is negative, but this is positive. A is 1. A is 1, E is 3. That P is negative, but the absolute value is positive. Okay. Then huh? Okay, then at x equals, let's just take P is 2, right? 2 times 1 plus y equals 1, z equals 0. Okay, good. 3 plus y plus r z squared equals 3. Y equals minus rz squared. And r is a negative. B is 2. Is r a positive? Is P smaller than 0? P is larger than 0. And P is larger than 1. And R is, how to find R? We'll just do like y is 0, z is 2. Is r positive or negative? One more time. Why am I overthinking, bro? Let's do this again. Z is 0, which I can also see. Notice y is 3, x is 0. Then p0 of a 1, right? This is a, minus 3 equals e, right? So e is minus 3, that's 1. A is 1, that's 1. Then at z equals 0, we have the equation p of x at 1 minus y equals minus 3. So we have y equals p of x, px plus 3. Right? We're trying to find p here. We're trying to see if we can get an equation for y. Notice that at y0, x is approximately 7 minus 7. So 0 equals minus 7p plus 3, which implies that 7p equals 3. P is approximately, let's just say, a half. So P is larger than 0, and the absolute value is less than 1. Okay, so that's a couple things. Right? Then look at x equals 0. Right? X equals 0 means, well, a half times 0 to the 1 minus y plus rz squared is b is equals to minus 3. So minus r plus rz squared equals minus 3. Y equals rz squared plus 3. Since on y and z, r must be negative, because there's no plus r here. R is less than 0. Therefore, we have p larger than 0, this p less than 1, b is 2, a is 1, r less than 0. Is that all 5? Yeah. And e equals minus 3. Minus 3. A is 1, b is 2, p is larger than 0, absolute value is less than 1 and r is less than 0. Hell yeah. Let's make sure one more time. I do not want to fuck this question up. Okay, let's do this question again as well. This, and this. 2. Okay, let's look at this equation, right? Z is 0. Then we have minus y plus r, sorry, px, a is 1, right, minus y equals e. Then notice x equals minus 5, y equals 0, and y equals minus 2, x equals 0. Okay. Then we're going to use the one with the y. Then this one gets, right, this one gets our e, this one gets our p. Yeah. So 0 minus 2 equals e. So e equals 2. Done. And then we have this, which is minus 5 times 1p equals 2. So minus 5p equals 2. P equals minus 2 on 5, which implies that p is less than 0 and p is less than 1, or the absolute value is less than 1 as well. Then z equals 0. What do we notice about z equals 0? We notice, then at x equals 1, we notice z equals 1, y equals 0, that's a pair, and y equals 1.5, sorry, negative 1.5, z equals 0. Okay, then we have minus 2 on 5 times 1 to the 1 minus y plus rz squared equals 2, right? Yeah. Minus 2 on 5 minus z plus rz squared equals 2. You plus that, plus 2 on 5 on this side. What do you get? You get what? This is a 12 on 5. So minus squared plus rz squared equals 12 on 5. So let's bring that to here. So we have y is equals to rz squared minus 12 over 5, which is, then we're looking at, right? So r must be larger than 0. Therefore, we have e is 2. E is 2. P is minus 2 on 5. A is 1. B is 2. P less than 0. Absolute value of P less than 1 and R larger than 0. So E is 2. P2 is less than 0. A is 1, B is 2. R is larger than 0, and this P is less than 1. Good. That's notes that we have. So now we have, in the left picture is this with the plane y is b. So this is x, b, and z. This is z, a, and y. And we have that parallel to the tangent line. So parallel vector to tangent line in x direction is given by 1, 0 df df dx, which is equals to 1, 0, and then the slope right here, minus 2.1. And perpendicular is equals to 0, 1, the f, the y, which is equals to 0, 1, and then the slope is minus 1 over 2.3. 1, 0, minus 2.1. This one is 0, 1, minus 1 over 2.3. And then we have this, which is the computing. C gives the cross product of these two guys. So we're going to use Maple, and we're going to go with linear algebra. We're going to open df dx is equals to 1, 0, minus 2.1, and df dy is equals to 0, 1, and be careful here, it's 2.3, it's not the negative. And then we're going to do cross product of df dx, df dy, close that shit. Then we're going to scale the answer by 10, so you can get that. Okay, let's see. 21 minus 23 and 10. Right, and then we have these values here. So 21 minus 23 and 10. The total linear approximation is equals to partial derivative of f times the change in x plus partial derivative of y times a change in y. And this is given by where the f to x is minus 2.1, the f to y is 2.3. So we actually have minus 2.1 times change is a plus 0.9. So that's our, this is b minus 0.8. So that's it. 0.9 plus 2.3 times minus 0.8. So we have minus 2.1 times 0.9 plus 2.3 times minus 0.8. That gives us that. So we should get everything right. Clean. This question is, you see 1, 1, 2, 3, right? We're going to turn this off. So we see it this. In the plot, select the two subsets that do not form a basis, right? So this does not form a basis. Done. Okay, 1, 1, 2, 4. That's fine. 1, 2, 5. That's fine. 1, 3, 4. That's fine. 1, 3, 5. That's fine. 1, 4, 5. That's fine. Right? 2, 3, and then we need a 2, 3 plane, first of all, and then 4. That's fine. 2, 3, 5. That's fine. 2, 4, 5. This is a 2, 4 plane. And a 2, 5 plane. Completely fine. And a 3, 4, 5. Which we see right here. That happens. Done. Okay? For each of the first two sets, Lantern times it thinks that this forms a spanning set. To prove this, they could think that for every vector in R3, we have this. For every, for some. So we could create for, yeah, so there are a list of, for every single total vector in our spanning set, we can create it using some of these 4 vectors. On the other hand, they think that this is not a set. So we want to say, hey, there exists a non-zero vector such that there's no choice. So that means no vector could be created. And we want to talk about linearly independent. So we want to talk about linearly independent. Before we click onto the button, we talk about for some vector v. No, for vector v equals 0. Yeah, vector v equals 0. Then we have only if that happens, only if our scalars are also equals to 0, such that that equation evaluates to 0 as well. On the other hand, they think that Z1, Z2, Z3 are linearly dependent. So how could they do this? They could check that there does not exist. There are, there exists a non-zero vector here. Vectors equals 0 for some b1, b2, b3, which are not equals to 0. Assuming that lands are correct in parts 1 and D, we want to say that set 1, 2, 3, 4 cannot form a basis, but set neither of these guys can be basis because y1, y2, y3 is in R6. Okay. for set for u1, u2, u3, u4, there are the basis for R3 for dim there are 4 vectors for the basis of R3. A basis consists of a linearly independent set and spanning set for R3, which means that there are exactly 3 vectors, 3 linearly independent vectors, or the dimension of the vector space needs to correspond to the number of independent for the number of linearly independent vectors needs to correspond equally to the dimension of the vector space, which is in this case 3. Since it could span R3 but could not be a linearly independent set for y1, y1, y2, y3. There are 3 vectors that is a subset of the vector space R6, which also means that basis needs to consist of 6 linearly independent vectors, at least, to span R6. Since this set only has 3 vectors, it may be a linearly independent set, but cannot have enough linear independent vectors to form a set that spans all of R6. Oh, let's see if we got everything correct or wrong. What the wait, we're cooked. Wait, we just got dogged. There are no vectors in... It's not a spanning set. There are no vectors. There exists a non-zero vector. Huh? Okay, I guess I wasn't dogged. They fucking lied to me. Holy sh! I was like, am I that bad at math? No. Come on. I have my theorems right, bro. Don't play with me, son. My theorem skills are not bad, bro. Wait, just to double check. Okay. That's retarded. Next, we have this question. This is a linearly dependent set. We're in polynomial degree at most 2. So that's with space 3, by the way. Select all options that are correct and correct reason. P1, P2, P3, P4 is a linearly independent set because column A has more columns than rows. I agree. And it is a linearly independent set because U has one or more non-leading columns. Select all statements that are correct and correct reason. It spans R2. No, it doesn't span, though. It doesn't span because it has a row. Yeah. Write the dimension of span 2. And I want to find a set which has the most polynomials possible. So we want to use P1. P4, E2. P1, 2, 3, 4, 1, 2, E2. Okay, good. 0 would always form a 0 vector. 0, 1 looks like it cannot be computed, eh? Nope. Undetermined. And 1, 1, 1 is equals to that plus that. So I'm gonna just add that together. Minus 3, sorry, minus 7 minus 3, and minus 6, 3. Minus 13, 0. Is that right? Yep. Or minus 13, 0. Compute. This is already computed above. This is already computed above. This 1, 0 is equals to this one, eh? So it's equal to this one minus this one. Yes, minus 6 and 3. Okay, I'm going to create a vector C, which is minus 7, 8. Now do B minus C is that. So 1 minus 5. I'm just trying to speed through these. Okay, good. Okay, vector spaces for linear transformation for these questions. Sorry. Right. T of 1 is 1. Impossible, because the domain wants a vector. T v1 plus v2 is equals to w1 plus w2. That's fine. These two are fine. This is fine. This is fine. Yep. Okay, we can linear solve here and then find the matrix. So we have this is that, and we will find it with that. So what we'll just do is new document with linear algebra, linear solve. Sorry, we want our first vector. Yeah, to be 3 minus 1. Second vector to be minus 1, 1. And we want E1 to be 1, 0. And we want to see how that's made. So, yeah. Actually, we have to create one big matrix. Like this. Like that. Okay. And then we're going to linear solve. A augment E1. Which gives us half-half. So beta's a half, alpha's a half. And then this is the same linear combination. Now we're trying to find E2. 0, 1. Sorry, 0, 2. Oh, E2, sorry. And linear solve with E2 gives me a half and 3 halves. Right. And then for this matrix, what happens with this matrix is you can't really look at it like that. You have to see, okay, well we have quadrilateral A, B, C, D. We have A is that, B is that, C is that, D is that. We could use transformation of A and C. We're going to use A and C. Okay. Actually, we're going to use B. We're going to use B and D. No, I can't even see fucking transformation of B. Never mind. I'm going to use transformation of... So I'm going to call this M. And everything else related to M is M. So just to reset. And I'm going to have A is equals to the vector 3 minus 1. Right? B is the vector minus 1 minus 1. Oh, what the hell? And what's our output? So P is... Okay, so P is this thing. What's Q? What's my output vector? I want to see output vector of... What does A get transformed to? 1 minus 3, right? And our B earlier. Or did we do C or B? We did B. No, I'm gonna choose C. I'm gonna choose C. C is minus 2 and 1. Minus 2 and 1. And our output vector is going to be minus 1, 2. Minus 2, 1, minus 1, 2. Right? And then we're going to matrix multiply Q and matrix inverse P. Nice. Okay, secant integral. Secant integral is a... Oh, it's a fucking ugly integral, bitch. First sub-ugly integral. That's not just tan and whatever. So... I is the integral given by root 9x squared minus 1 over 8x dx. And they want us to notice that this is the same as a certain ax squared minus, sorry, we'll call it like qx squared minus ax. So we're going to whip out our integrals here, our substitutions here, which is minus x, yep, a squared minus x squared, x squared plus a squared, and whip out x squared minus a squared, and this is a secant and cosh integral, right? Because they also have this bad boy here, we should be looking at it's okay. They gave us let x equals a third secant t. Dx is equals to what? Diff a third times sec t. Sec tan. Right, a third sec t tan t dt. Then we have the integral of, that's okay. I know how to do this. We're going to do this function. Let f of x be a function that's given by square root of 9x squared minus 1 over 8x. Right. Subs x is equals to a third of sec t into f. Multiply this multiplied by this. No, I shouldn't do it like that. I should do, we have 3 sec t squared minus 1 on 8 sec t times a third sec t tan t dt. That cancels. And since we know that, we should have, where's my black pen? This one. Well, I know that 1 plus tangent squared is equals to secant squared. So secant squared, tangent squared is equals to secant x squared minus 1. So that's basically equals to tangent t on times secant t tan t on 8 secant t. So what we do get is the integral tangent squared t on 8 dt. Whew! What's f of t? F of t is a third times sec t tan t. And g of t is tangent, sorry, we're going to do 1 over 8 times on the outside, tangent t squared. Tangent 1 over 8 tangent t squared. The computation of the integral above results in the integral tan over 8 minus t over 8. In order to write this expression, it's convenient to draw a triangle where t represents one of the acute angles. So tan minus t, we know that 1 over third t is equals to x. So what is t, by the way? T is equals to, honestly, I think I'm just gonna guess here. It's gonna be 8. Nope, my bad. It's not 8. Oh, secant of t. Secant of t. Is secant, oh, secant of t is 1 over cos. Oh, I know now. Easy, easy, easy. Since we have x is a third secant t, this implies that secant of t is equals to 3x. And this is the same as 1 over cosine of t, which is basically 1 over ka, right? Which is 1 over hypotenuse, adjacent over hypotenuse, which is equals to hypotenuse over adjacent, which is equals to 3x on 1. So we have a hypotenuse of 3x. We have an adjacent side of 1. I think 1. Yeah, 1. Therefore we have 1. Okay, draw a triangle. Basically, figure out what the trig function means, and then solve the integral. Yes. Figure out what the trig function means, and then solve out the integral. Consider that integral. Okay, I'm considering it. Sorry, bad joke. Integral 1 over e to the 8x minus e to the 4x dx, right? Let u equals e to the 4x. Then du is equal to the 4 e to the 4x dx. Right? So if you divide that, you're going to get a 1 over, is that u squared? Yes. Minus u times du over 4u. Is that right? 4u? 4u. Which is the integral 1 over 4u squared u minus 1 du. Okay, nice. So the under, this is gonna be that times u minus 1. Using the standard partial fraction decomposition, which we'll use par frac on Maple, so who gives a shit. Par frac 1 over this whole term, sorry, what we meant is convert 1 over that term, par frac u. We would have a, sorry, thank God, because there we go. We're going to have 3 terms, and then one of these terms is in this form, u minus 1. Provide the value of a. A is going to be 1 over 4 here in this case. And then the integral is that. So I think we just integrate this as well. Open bracket, integrate the integral. Sorry. Open bracket, integrate with respect to u. We get that. Then we factor the 1 over 4 out. So one sec. So this is equals to 1 over par frac 1 over 4u squared plus 1 over 4u minus 1 minus 1 over 4u. Then integrate. I could learn the integration steps again, but like, fuck them. We'll get 1 over 4u minus ln u on 4 plus ln u minus 1 on 4. So we're going to factor the 1 over 4 out, and we got 1 over u plus ln of u minus 1 over u. Is that right? Yep. And we see that b is 1 and a is 4. B is 1, A is 4. Nicely done. We're going to... Nice paper. No mistakes made on the paper. Annalise and Tristani would like to solve the following ordinary differential equation. If you divide that over that, we would have a first order differential equation that is not separable. And we have a trivial solution where everything is equals to 0. And then we also have this equation where it's now a separable differential equation. And it is not linear, is it? It's not linear. Or is it linear? No, it's both divided on x. It's not linear. Linear, ordinary, exact, first. This is a first order differential equation and a separable, right? So we can par frac it into that. So what they want us to do is look at dv over dx is equals to v cubed plus 4v on x. And we want to transform that into the integral v cubed plus 4v. Sorry, shit. The integral of dv is equals to 1 over x dx. Yes, 1 over x dx. And then they want us to par frac that bad boy into that. So once again, we're just going to par frac everything we see. V cubed plus 4v. Par frac that bad boy is 1 over, so that is equals to the integral of 1 4v minus v for v squared plus 4 dv is equals to, well, right hand side is going to be ln x plus c. Okay, I do see a 4 come out the front, which is pretty sick. Okay, well, firstly, we're going to get 1 over 4 here. B is going to be minus 1 on 4, and C is going to be 0 because there's no extra C. It's just V on 4 here. Okay, so we're going to integrate this as well. Respect to V. Yeah. So we get ln V on 4. Okay. So get ln V on 4 minus ln V squared plus 4 on 8 is equals to ln x plus c, right? So we multiply everything by 4 to cancel that out. That becomes a 2. So we get ln V minus half ln V squared plus 4 is equals to 4 ln x plus c. Yeah. I'll do minus half ln V squared plus 4. Half ln V squared plus 4. Everything else is fine. Yep. Okay. Differentiation. Okay, we're going to be differentiating partially the g of x part with respect to x. So we're just going to, by inspection, that 9y squared just goes away. If you guys see this, 9y squared goes away. This goes down by parallel to x plus 1. And then partially integrating with respect to y, well, that x squared part goes away. Now we just have, wait, my bad. 2x plus y. This is going to go away. This is going to be x plus 18y. And I'm given f of t is that. So we want to find some f of t. So f of, okay. So now we're given f of x and minus x is equals to, firstly we'll copy down our small f function, and then we'll input where the x, the minus x components need to go. Yep, is equals to right hand side. I'm just going to put right hand side so I can breathe a little bit. That's equals to minus 3x squared. So we have the function of f times what? Well, that's minus x squared, so that cancels, and we get 9x squared. F of 9x squared is equal to minus 3x squared. So let t equals 9x squared, and x squared is equals to t on 9, right? So we're going to put t on 9 back in. So we basically have f of t is equals to minus 3 times t on 9 squared, right? After that, we want to put this back into our big equation. No, 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 no. So f of t is equals to that, minus 3 times t on 9 squared. Now f of x of y, now we have to, how do we do this part? Guys, it does look like I just have to do all the questions. So not only do I do the core, I have to do basically the 2024, 2025 questions. 2026 questions. Okay. Think this is equals to -3 t squared on 81. Honestly, I don't know. How do I do this one? So this would be the answer, and this would be the answer. Okay. That means today I should be doing these questions and the load of the mothership of 2024 and 26 questions. And then tomorrow is like full on beast mode of grinding previous questions and past papers and everything. Okay, whatever. Okay. This question is, we're going to transform it. We're going to divide both sides by that big ass square root. And we see a substitution right away. Okay, so the integrating factor is going to be x cubed on square root of x squared plus 1. And because it's a x squared plus a squared integral, we're using tangent and shine. So a tan theta and shine theta. Shine and tan. And then we're going to evaluate by integrating it at 0. Yeah. So we want to integrate this fucking fraction, this thing at 0. So open bracket, integrate at x, and then exponent of, subs x is 0 into your answer, and we get minus 2 on 3. So it's going to be exponent minus 2 and 3. So integral of x squared plus x cubed. Oh, x cubed y? Oh yeah, x cubed. Great, and then e to the h of x. E exponent, open bracket minus 2 and 3. Okay. Okay, this is chill question. This is a, if we're going to differentiate by y, that, okay, this looks like a exact, find the normal, which is partial derivative, right? So we have x, h of x of 5. Then we have, this goes down to h respect to x dx plus h respect to y dy equals 0. And we have 16 x cubed y squared plus 12 cosine 4x dx. plus 8x 4y. Y is 0. Normal is partial derivatives at normal at 4 to 5. Sixteen, 4 cubed, 2 squared, plus 12 cosine 4 times 4. Partial derivative that way is x 4 cubed y, times 2 minus 1. 16 times 4 cubed times 4 plus 12 times cosine 16. Right. And then we also have 8 times 4 to the 4 times 2 and minus 1. So we have, this is our bad boy. 4096 minus 1. Find the tangent plane to the point and complete its equation. Tangent plane is the fucking z part plus the partial derivatives oh, it's like an x minus 3 type of thing, right? Yeah. So tangent plane is equals to z is equals to z0 plus hx at 2, 3 times x minus 2 plus hy 2, 3 times y minus 3. This is equals to 3 plus the given. Okay. 3 plus the given 1125 open bracket 1125 plus 12 cosine 8 times x minus 2 plus 384 times y minus 3. See if that's right first. Yeah. And then from this we deduce that the h is going to be partial derivative, right? So now they give me, sorry. Now they give me partial derivative h with respect to y is x 8x 4y, and if we integrate with respect to the y, we get this 4x to the 4y squared plus some constant in terms of x. Sorry, 4x cubed to the 4 times y squared plus some c of x, where c is a differentiable function of x, and then you want us to use to find partial derivative of this one. And so we're just going to, oh, we can't really partially integrate here, so no, I guess we could try the integral of 16x cubed y squared plus the integral of, let's put 12 outside, cosine 4x partial derivative. Okay. Well, we'll do that first. Okay. And then we have 12 times, well, cosine x integrates to 1 over 4. Yeah. 1 over 4 sine 4x. So we get, what do we get here? Okay, we get that. 3 sine 4x. 4x. Okay, so we always pull the trigger when we know, boom, everything's good. Let's move on. Okay, right away, right off the bat, we pull the f of t is equals to m1 over t over v1, which is equals to basically m2 m1 plus m2 is m. M1 is equal to m1 plus m2 equals m. So it's equals to m minus m2 over v1, which is equals to m over v1 minus m2 over v1. But m2, well, since gt is equals to m2 over v2, we have m2 is equals to v2 gt. So therefore we have m over v1 minus v2 v1 gt. Okay, and that is equals to m over, what's v1 here? v1 is 2700. What's v2? 12,960 over 2700 times gt. So if we simplify that, 12,960, maybe that works. Nope. 2700 gets us 12,960 over 2700. Okay, they try to throw us off, but it's chill. 24 on 5 gt m over 2700. So our m is minus 24 on 5. Then we have, this is 0. We have fucking dg derivative of g with respect to t is equals to f of t minus g of t on t, which is, what's f of t? M over 2700 minus 24 on 5 gt minus, what's gt? Gt is m2 v2t, which is, what's m2? Oh, I think we just write gt here. Yeah, let's write gt here. Yeah. So it's 1 gt. And all of that is divided by t, yeah, divided by t. So what do you get on the inside first? Well, that's basically equals to m over 2700 minus another 5, right? Minus this, minus that. Yeah. So minus 29 on 5 gt, all divided by t, which is equals to m over 2700 t minus 29 gt on 5t. Okay, let's just write that down first. Open bracket, m over, open bracket again, 27t, close bracket, minus 29 times g over 5t. See if that looks good. Yeah, that's what our paper says. So initial value problem, what we do is we have this equation, right? So we have dg over dt is equals to that. Notice that this is a linear, this is a first order linear ordinary differential equation. So we will add to both sides to get to the form g prime plus some value of, I don't know, pt of g plus equals some fucking value of t, right? Some u of, some f of t For this one, we're going to copy the first 3 columns of the matrix, like this. And we're just going to close that up. How do they end this matrix? Like that. Why is there an A in the middle? Ew! Wow, these bitches. They want us to do 1, 3, 4. Okay, so I have to do 1, 3, 4. Let's just copy it over first. And then we're going to delete the second column and the last column. So deleted second row and last row, 5th row. We need to create vectors like this for all. So choice 1, yeah. Oh, okay. Guess we do keep everything. Oh, okay. I think it's the same then. Which is 2 minus 2 and minus 1. Yeah, 72 times, right? Works. So you can get a cheat code here by using the last one. A5. 2, sorry, minus 2, 2, minus 2, 2, minus 1. One, 3, and 4. Yeah, that's fine. And then V. Which corresponds to what? First row, 3rd row, 4th row. So it's minus 12. No, minus 120. Yes. Nice. 0 here, if it's a lambda is 0, it's fine. But you want it's diagonalizable, but its nullity is not full. So -3 with 1, 2, 0, 1, 1, 4, 3, 2, 1. Okay, the generic case. 2, 4, 0, 3, 2, 1. What is 2, 4, 0? No, that's a linearly independent vector. That is a vector here that comes from this one, but not there. This is 1, 2, 0, 1, 3, 4. Is 1, 3, 4 a combination of that? That is fine. Plane. Test. Okay, that's makeable. So that works. Right. Factor determinant of R is lambda equals -5 with a algebraic multiplicity of 2. This means that it needs 2 linearly independent vectors to be diagonalizable. However, rank R1 is 1, and by rank nullity theorem, rank R1 plus find some matrix. Actually, I'm just gonna do it here. A plus B equals ba cộng trừ 3 cộng 8 bằng 5. 1 trừ 4 không. Open bracket of the set AB, right? Yes. root. How much is that? 149. Root 149 looks like a four, like a. Okay. So A and B, right? So D is equals to B inverse times A times B. So A N B Y. This means that A is equals to B D N B inverse, right? Which is A is A times okay. Missing some ends. Well, having a nullity, having x equals to 0 for the components in the diagonal matrix D means that any vector in any component in any column component basically gets crushed down and gets sent to the zero matrix. Since this is a non-trivial solution, that are mapped to a zero matrix. Y would not equals 0. Oh, fuck. Problems. Big bag of problems. That's just my math, bro. I always get this question wrong. I don't know why. Why do I always get that question wrong? If you see the red part, I continually get this third component wrong almost all the time, but I don't really understand why I keep getting it wrong. I would just solve an times b times y, and we get those. We get a matrix multiplication of that. But when it's time for me to copy things in, like, it just never really is correct. Tell me why. BDN, yeah. Is that my fault for... It's always my... It's me copying down the wrong fucking question, bro. me copying down the damn question wrong. Okay, I'm gonna flag 22. Okay, I'm gonna flag 22 as a wrong question. No feel for it yet. Yeah. This series, they're asking if it converges or diverges. Five on two. Should converge. Right? Let's say log k is less than k to the 1/2 for large enough k. Then log k on k 5 on 2 is less than k to the 1/2 over k 5 on 2, which is equals to 1 over k to the 2. And this one converges by p-series. So that's comparison test and integral test. Okay. Alright, this is a 2025 question. Flat, positive. Also, x0 or a is that. So this is flat here. Positive is here. This is a negative curve, positive. Negative. 6.8 minus 6.8 here. The value of a is not necessary, but it would be necessary for some. And then we have considering R6, 0.5 is equals to f of 6, 0.5 minus 0.3 to the 6 on 6 factorial, which is minus 6.8 times 0.2 factorial on 6. Sorry, absolute value. Sorry, to the 6a. This is a polynomial of degree 7. Let's see this. Alternating series Firstly, you're going to try to use for a test for absolute convergence, right? So for A part is test for absolute convergence, which is equals to the a kth term as positive, which is equals to this k plus 9 times ln k plus 4 over root k plus 2 is approximately like k times ln k over k squared, which is more or less k squared times ln k. So that goes to infinity, so diverges. Diverges by the kth term test. That looks phenomenal, by the way. But that is basically 1 over k. It's smaller than 1 over k, though. So we're also going to use test for absolute convergence. One over k plus 4, basically, which is less than 1 over k. So will converge. That's basically 1 over, but it's less than 1 over 4. But it'll converge by comparison with the PC. Will that diverge? No, it's basically equals to 1 over k. Basically equals to 1 over k. So will diverge at large k. R. C is a k squared over k plus 6 times k to the half. Okay, so usually I just strip away of everything. I have k on the top, I have k squared times k and a half, which is basically 1 over k times k of a half, which is 1 over k3 halves. So that looks like it will converge by comparison with the p-series, right? So converge by p-series. C. That 8k over k squared, it's it's larger than 1 over k a couple times, 8 times larger actually, so looks like it will diverge of what? 8k plus 2 on k plus 1 squared, which is approximately 8k k squared, which is 8 over k, which is larger than 1 over k. So divergence R. That looks like the ratio test, fortunately. K plus 4 to the k. So we're going to use the ratio test. And we're going to see, well, ak plus 1 is 2 to the k times 2. K plus 2 times k plus 1 factorial over k plus 5 k times k plus 5. That's over 8k, so limit at 8k is equals to, well, I just split it up, so I'm just going to do k plus 4 to the k here, and 2k k plus 1 factorial. Cancel the k plus 1s, cancel the k2s. Now we have 2k plus 2 times k plus 4 to the k over k plus 5 to the k times k plus 5. Okay. We could do, we're gonna evaluate to see if it's larger than 1 at large k, right? Yeah. So I'm going to do something like open bracket 2 times k time 2 times k plus 2 times k plus 4 to the k over k plus 5 to the k, sorry, k plus 1. Okay, and then subs k is like, I don't know, 100,000, million into answer. Let's just eval. So that is less. So that is less than 1. So it will converge by ratio test. B. I don't know. I hope it's right. Nice. Okay. Good. Good mathematics. I am cooking mathematics. Okay. We're going to find upper bound and lower bounds. And then we're going to try to grind 2026 and 2024. And then call it a night. And then tomorrow we're grinding past papers under time condition. See how we go. Twenty questions until from now until what, like 3 to 4 a.m. Bây giờ 5 tiếng rồi. 5 tiếng cày được 26 câu cũng được. Nhưng mà mấy câu này học rồi á. 5 tiếng cày được coi như là 2 bài đi, nhưng mà phải nhanh hơn. Cái thứ hai là mình dành tầm nửa tiếng đến 1 tiếng đầu tiên là để học lại mấy câu này, giải cho nó thuận, để đỡ để quen tay ấy. Giải cho nhanh. Ok, thôi giải tiếp này. We have these lower and upper bounds. We're gonna put f prime is between that and that. So lower bound. I'm just gonna write it lower bound. Is the integral from 0 to 10, 2 pi times 3 in this case, times 1 plus 0.32 squared dx rounded down. Eval int open bracket 2 pi times 3 times square root of 1 plus 0.32 squared. Do a closed integral from x is 0 to 10. Which is 197 point, okay, 197.911, which rounded down is 197. Upper is, fortunately we get to use it, which is a lot nicer. 0.71. which is equals to 693.5 rounded up. 694. Okay. 197 to 694. Let's just make sure we're around 430. So, sorry, 435, which is right around that sweet spot. But then we could use better bounds, which is f0 is that, and f whatever is that. So better approx, just to make sure we have 2 pi of f0 is 3 plus mx, which is 0.232x times the interval 1 plus 0.32 squared dx, and integral 3 plus 0.71x 1 plus 0.71 squared dx. Okay. Come on, let's breeze through this. Open bracket here, 3 plus 0.32x times whatever that was. So you round down, you get 303. This one, you want to 3 plus 0.71x, close bracket, and you get 505. 303, 505. Nice. I'm going back to 5:05. If it's a second hour flight or a 45-minute drive. My imagination, you're waiting, lying on your side, with your hands between your thighs, and a smile. And a smile. Stop and wait a second. When you look at me like that, my love, what did you expect? Do 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 do. Do 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 do. I'm going back to 7-hour flight or a 45-minute drive. In imagination, you're waiting, lying on your side. Just love between your thighs and a smile. We're asked to compute some cosine 2x sine 3x. Okay. Right. But you'd be subtracting, eh? Sine A cosine B plus sine A plus cosine B is equals to what? Let's see. Let's do sine A plus B is equals sine A cos B plus cos A sine B. And we want to subtract the minus so that we get plus. Yep. So we want to subtract sine A minus B, which is equals to sine A cos B minus cos A sine B, so that we can get this. 2 cos A sine B equals sine A cos B minus sine A minus B divided by 2. So we have sine of 2 plus 3 minus sine of 2 minus 3 times a half is cos A sine B. Sorry, that's equals to sine 5x minus sine of minus x, but once again, because it is an odd function, pretty sure you bring it out the front. Yeah. Sine 5 of x plus sine x equals cosine 2x sine 3x. So A should be 5 and B should be 1. We should use a change of variables here for u cubed. Well, should we use the odd one? If we use u is 10, derivative of 10 is sec squared. Yeah, so we're left with u cubed, and then sec squared gets absorbed into du. Tan x. what do we need? We want to go from integral of minus this to 0 of cosine 2x sine 3x plus the integral of 0 to pi on 6 of 10 cubed x times sec squared x dx equals this one, right? Yeah. Minus 3 on 5 plus root 3 on 5. Okay, ugly ass. Plus 0 to pi on 6, which is 1 over 36. Okay. And then in the average is, well, the interval f average is equals to 1 over b on a of the integral from a to b of f of x dx, which is equals to 1 over pi on 6 minus, the difference between pi on 6 and minus pi on 6 is 2 pi on 6, right? Times the integral, which is minus 3 on 5 plus root 3 on 5 plus 1 over 36, which is what? 6 on 2 is 3 on pi times whatever we just talked about. Ugh. 3 over pi times minus 3 on 5 plus square root of 3 on 5 plus 1 over 36. By mean value theorem for integrals, since the limit of the left hand and right hand side of the integrals do match up at 0, f is continuous for the whole interval from minus pi on 6 to pi on 6. So there must, by the mean value theorem for integrals, could treat it similar like a function in that right? We can compute the limit of the integral of cosine 2x sine 3x from x is minus pi on 6 to 0, x to 0 plus 0, 0 plus. Oh, is it? just about to... Wait, maybe not in this case, because they don't match up. Fuck you, bitch. Do the limits of the integral evaluate to 0? Or am I getting cooked? What are the limits from 0 from the left and 0 from the right? Because I want to be able to use mean value theorem for integrals. Is this how I would approach this question? Okay. Pocket aces, brother. Pocket bullets. Pocket bullets. I will integrate alpha and make sure that the continuous random variable becomes a cumulative density function. Right now it is a probability density function, so I will integrate and solve for a. So I will solve, open bracket, integral times a times x squared minus 4x minus 5 x between 1 to 5. Sorry. Does this close the integral already? We want that to close, and then we want to solve for a. Sorry, this equals 1, and we want to solve for a. That's my value of a. And then now I want to find the expected value, which is the integral x over whatever, right? So now I just want to eval this integral times x, minus 1 over 36 times x times whatever that is. And that's 2. Okay. Okay, so we should draw this. It is a continuous random variable with a probability density function. So it is a continuous and symmetric about 8.5, right hand side being 12, left hand side being 5. Okay, let's start with the first one. Px equals 8.5, 0.5. Okay, second one. Px is less than 8.5 is the same as Px is more than 5. Yeah. Correct. 9.5 to 12. What's the distance here? 2.5. And 9.5. This is smaller than 9.5 to 13. Not smaller. Same. 8 is less than or equals to this. Yes. This is both equals to 0. Right? Probability density function that x is larger than 8.5 is larger than probability density function of x is larger than 7.5, which is wrong. So just 2. Good. Good, 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 good. Ooh, this is the fun one. Let's see. Let's see. Okay, 6 faces and 3 faces. 3 faces and 17. Probability. Dice. Select your die. Selector. Half red, half blue. We've got red die. 3 out of 20 win. 17 out of 20 lose. Blue die. 2 win. 2 out of 12 win. 10 out of 12 lose. Okay. Probably P of winning game, which is equals to probability that they get red and they win plus the probability that they one half red plus a blue win plus or half blue and blue win. Basically, right? Well, this is tough, bro. Yes, I agree. So that's with no conditions. No conditions whatsoever. Red and red win plus probably red, a blue, and blue win. Three on 40 plus 2 on 24. B. Given 1, what is probability 1 with red? P red and red win. 1 half times 3 on 20. 3 on 40 over P2. Works. It's called a colored. Given that at least one of the colored dice turned up win, what is the probability that a player did not win? So probability dice at least one win is the same as 1 minus probability that no dice turned up win in both orders, right? So it's 1, this is red or blue, red and blue, times red no win times blue no win. Which is equals to 1 times 1 times red no win is 17 over 20 times blue no win is 10 over 12, which is equals to 1 minus 170 over 240. Yep. And probability of did not win. Probability player did not win. Probability red die times blue die win times red die lose, or P blue die. Red die win, blue die lose. Half times blue die win times 17 lose, plus half times red die win times blue die lose, all over a half times 2 on 12 times 17 on 20 times plus a half times 3 on 20 times 10 on 12. Let's firstly see if that works. Yep. All over 1 over 17 on 24. Oh, hell yeah. Probability of winning the game without any conditions was if the selector die came up red and our red die also had win, or blue die came up selector or selector die came up blue and our blue die also had win. So plur selector die probability win. Given that the game was won, which was our probability before, we now want to see the probability out of that we actually won with red. So probability of red win as a proportion of the percent of the probability of winning at all. 0 to 40 over so we'd find the probability. Firstly, the hard part is finding the probability of a colored die turned up win. Turned up win. This could be cases like this could only be cases where the die either so regardless of the probability of the selector die, we'll look at the probability of the red and blue die getting either at least one face up win. The only probability where that doesn't happen is the inverse. So 1 minus probability of none of the dice getting win face up. 1 minus 17 over 24. The probability that we, hence the numerator would need to also kind of be connected. So the numerator to have the probability player would lose, given that had won that This is not the final question. Jeez. I'm shattered. Only 5 hours in, 6 hours in to basically finish all the questions. Woohoo! Yeah, buddy! Yeah, buddy! Lightweight, baby! Where's my monster? Medquat, Vaikuda. Yeah, these are all good products that I bought. Okay. We will have x defined by a random variable. Sorry, was statistics x defined by a random variable. That follows a what? A mean of 3 and standard deviation 2. Mean is 3, standard deviation 2. Calculate probability x less than 3.3. Probability. Hannah's favorite part of mathematics is geometry and thinks it's a good idea to mix geometry and probability using random variables defined above. What's the probability that the point R lies on the horizontal line with the equation y equals 5? So on the horizontal line, well, it's on the horizontal line. Y is 5. So no matter what x is, y is 5. So okay. Y is random variable binomial 19 0.21. Probability y equals 5. Okay. Write a vertical line AD means larger than 3.3, right? if it is known. Is it not? Is that not less than or equals to 4.7? I just gotta trust my gut here. On the right of the vertical line AD, if it's on R lies above CD. So probability of, I shouldn't be speeding through these. These are unseen questions. Probability right of AD means probability that X is larger than 3.3. Probability that R lies above CD, which is probability that Y is larger than 3.3 as well. So multiply, I'm assuming. Probability of Y being larger than 3.3. And probability that X is larger than 3.3. I don't know. These two times. I hope. Between the horizontal lines AB and CD. AB and CD. Like that. Probability Y is less than 5.1 minus probability that Y is less than 3.3. So this is an and an or. This is an or and an and question, right? So she's admiring Hannah's work and decides to do the same but with a different random variable. We're cooked. Wait, we're cooked. We're cooked. We're cooked. We're cooked. That's like $2,000. I'm just making a mistake. $2,000. There's no fire pit down. Oh, that's your mom. He's gonna send a bill. Wait, why? Because that costs electricity or some bullshit. You can bring your back out of your mom. Wait, all I did was make a mistake. There's no way that the whole time without. That sounds really good. Do I get free steak? No. what is the probability that point R lies inside the rectangle? It's an and an or question, right? So it's that plus that times that, or it'd be like this times this. Yeah. Or E times F, maybe? Plus Oh, would you add these? Wow, I got a lot wrong. Oh, or is this plus this minus this. And then I got these two wrong. Is it conditional probability? D part is conditional probability. Weird. So D part and E part are conditional probability. Wrong. E part, probability that R right of 80 given left of BC. What's left of BC mean? Which is P of X is less than 4.7, and probability that P X is larger than 3.3, which is E. This is D. E is probability that R is on the right of 80 given R lies above CD, which is R is above a 3.3. Y is above 3.3. X is above 83.3. Px larger than 3.3, or Py is above 3.3, and this one is X is above that. Okay. Is it because they're mutually exclusive? Okay, this is a big question to basically do again. I want to do this question over 31. 31. Let's be very, very slow with this and just clear everything and think it through. We have X follow a with statistics, we have X follow a random variable, normal. We have Y follow a random variable. We have probability that X is less than 3.7 is that. Okay? And probably that R lies on the horizontal line with the equation y and 5. On the horizontal line, which is horizontal line equals 5. And horizontally it's okay. So probably that y is exactly equals to 5. Like the y coordinate is equals to 5. Probably that r is to the right of the vertical line AB, so on the right, which is larger than 3.7, right? So probability that x is larger than 3.7, and the probability that r is on the right of vertical line AD if it is known that it lies on the left of BC. So it must be between AD and BC over the probability of it being left of BC. So D part. We draw it out, right? So the probability that it is on the right of BC, and on if it is known that it's on the left, so it's within that divided by probability that it is left of BC, which is P of x is less than, what's BC? 5. So it's a probability that x is between 3.7 and 5 over the probability that x is less than 5, which is, so probability that x is less than 5 minus probability that x is less than 3.7 all over probability that x is less than 5. Okay, my iPad just died. Valve, please. Sorry. Larger than. There you go. Yeah. And answer should be divided by probability that x is less than 5. What's the probability that the point also lies on the vertical line? I just know that this is the same number, and this is between, so E and D, if we route learn, C and E are the same. What's the probability that point R lies between the horizontal lines A and CD? That's Y. That's random variable Y. Probability that Y is less than AB, which is 5.5, minus probability that Y is larger than DC, which is 3.9. And then this is route learnable once again. And this is equals to the, please. Y is larger than A. R lies between the horizontal lines. AB. Upper limit is 5.5, right? And lower limit is 3.9. So probably the x is larger than 5.9 and smaller than y 3.9. Why the hell not? What's going on? On the right side of AD, so that's larger than 3.7. And less than BC, which is 5. Why the hell not? Oh. My iPad just died. Oh yeah. What you way? So sad. Left of BC is x is less than 5, right? Probability that x is between 5 and 3.7. Should give me that. I don't know why. Why the fuck? CDFY 14.7. See. CDF. This is here, right? BC is 5.5 height and 5. So it's 5. CDF of Y is 3.7. Okay, this number minus that number. 0.282. Okay, CDF X minus BC is 5. Minus CF is 3.7. Is there something to do with my distribution? Mean is 3, deviation 2. Yeah. Zero point 0.24. Huh? Huh. Use CDF and it works. Use CDF and it works. Have to use CDF. Use CDF. CDF X5 minus CDF X 3.7 over CDF X5. Man, I'm so hungry, bro. Chín rưỡi rồi, đói. macro factor. I have eaten at quite about 6 p.m. 250 gram strawberries. Sorry, frozen strawberry. Honey, 10 G's. Cinnamon, 2 G's. Musashi, log. I have about 300 calories. And it's purely into protein, so maybe I get another protein bar. Protein bar. Very good luôn. Let me just finish this question. It produces a packet normally distributed with mean mu and a sigma is 9. Okay, then if mu 6, 7, 5, what's the probability of x being less than 6, 6, 5? Is what they're asking. With statistics, x is some random variable, normal. Mu is 6 and 5, so maybe it's just 9. What probability? X less than 665. Come on, bro. CDF. Eval. In order to make the proportion of weight packets at most 25 over, okay, so goal is underweight only 25 over 10,000, which is I don't know. Okay, 0.0025. Do we find a quantile? Divide by var or divide by standard deviation. something like that, right? Quantile. Yeah. Quantile known area. So we set, right, which is equals to Z I forgot how to do this question. I'm cooked. Oh, okay. That is our alpha already. Alpha. If I have that, that's fine. Okay, I have to flag this. The two bottom end probability questions are relatively like poorly done by me. 22 core group. 22? Q31 core group. I'm still very uncomfortable with these. Q32 core group. Q33 is less than right. Okay. Fundamentally, P Z less than 2.26 given Z larger than 1.26 is equals to probability that 1.26 Z 2.26 over the probability that Z larger than 1.26. Right? So CDF Z 2.26 minus CDF Z 1.26 all over CDF Z Oof. Nice. This should be like stuck somewhere so that I know that I have a list of questions I must be able to perform over and over and over. I'm gonna get a quick dinner and I barely have any calories left for the day. If I added a burrito, how much in calories would I get? Huh? Say I added a burrito. 21. Ăn gì được ta? Trứng ở nhà có trứng không thì ăn trứng. Ăn trứng với lòng trắng trứng, mấy quả trứng là được. Đúng rồi. Ăn lâu cắp có miếng phát nữa vô là ngon. Đói quá.
team B and D, like not even allowed to
Oh,
D&D.
and then the next screenshot.
And then the next screenshot is Hype League. I don't fucking know. Wait, that's it. Why would how can you expect anyone to believe he made that? Yeah, he did, but like I don't know what he posted. Anything on top of the table, like, sure.
you guys in like 2 days. Okay. We're gonna. This is way too many calories for me today. We're gonna drink our vitamins and the Vicks and everything in between. A day of just sama Pinoy sa Pulita boy. Okay. 2024 T2 T3 on our iPad. Fortunately. Shit, something just fell. That's fine. It's nothing. Messy shit. We need to chat GBT our way and try to finish as many of these questions as possible. I think I just shot this. we'll do 5 questions. Go take a shower. 2026 questions. 1, 2, 3, 4, 5. 5 questions. He said that this question is it. Let V be a vector space over R and let V1, V2, V3, V4, and V5 be vectors. Okay, wait, before. We gotta download them. Moodle. Mixing. Vijf, good. Okay. Wow. That looks hard. Do we have the... Let V be a vector. And let... Ow. Linearly independent vectors, but not a spanning set for V. Use a non-zero linear combination V1, V2, and set U spans V. Okay. Okay. Set S union vector spans V. So the dimension of V should be this. The fuck? 4. Come on. Dimension should be here. Hello? Oh. Right? Because S or set contains shit, what happened? No, now's not the time, boys. Not the time to fucking be a dumb bitch. If V1, V2, V4 is the matrix of the columns V1, V2, V4, then rank of A is 3. It is a non-zero linear combination. Wrong. Wrong. Yes. Because V4 equals alpha V1 plus beta V2. Alpha let V1, V2, V4 be the matrix of the columns V1. There's not enough information. Nope. The dimension of span of V1, V2, V5 is 3. Yes. Let's just check if we are right on that. Okay, that wasn't too hard. It's normal math. It's not the hardest question that they could have fucking given us. Sorry. Maybe I'm so tapped in, brother. Okay, so I would choose that. Choose that. And I choose 3. Nice. Select the statements below about the linearly independent that are true. That is not linearly independent. One, 3, 5 is linearly independent. Vectors 1 plus 4, 2 plus 4, and 3 plus 4 are linearly independent. Some needed linear combination that this is V3 plus V4 is V1 plus V2. Yeah, I agree. What about this one? This is a combination of 3 linearly vectors. V1, V5, both linearly. Yeah. We know that this is true, right? Do I know this is true for sure? Do I know that this is true? Why? But this is probably true. So is it like this? Hmm. Oh, okay. I think I know why. None? Pharmaceutical company fills bottles using two machines, machine A, such that 75 are filled by machine A and 25 by B. The volumes filled by both machines follow normal distributions. The volume filled by machine A follows a normal distribution with the mean of that and standard deviation of that. Okay. This is me with our first try. A where's my shit? Forgot. Right. Then probability of larger than CDF. A is what, 377? Okay. This times 10,000. Nine 158. Nice. Whenever you're asked to calculate probability, enter it as a decimal correct to at least 4. After machine A is replaced, machine A breaks and is replaced by a new machine called machine A2. Machine A2 is different because 89.44 of bottles, so the quantile 0.8944, are acceptable. It's also known that 78.81% of the bottles are acceptable. Like before 25 bottles are filled by machine B and 75% by machine A. Calculate the probability that a randomly chosen bottle produced by the factory is acceptable. So the probability that is acceptable again, straightforward, not too crazy. Uh. 0.8944 times plus 0.78. Okay, if a bottle produced by factory A is acceptable, which is that probability, right? Let's call it produced by machine A. Oh, nice. Given acceptable, probably A acceptable over probability acceptable. Okay. So what I'll do is this over that. The volume filled by machine A follow normal distributions. It is known that the mean volume filled by machine B is 2 points less than the mean volume, and that the standard deviation is the same, given that 89.44 are acceptable and that 78.81 of the machine are acceptable. Find the mean volume filled by machine A and the common standard deviation, both correct to at least 2 decimal places. Okay. So okay, target is what? Let's go with target acceptable is 377 milliliters. Quantile A Then we have Z is a random variable normal equal 1 quantile Z is equal to 0.8944 1.250272. Alpha's what? Okay. I was able to calculate the probabilities and stuff, and I was also able to kind of understand that, well, the acceptable target range is larger than 377, right? So if I were to quantile, I quantile the 0.8944, so the first 89.4%, or there's an 89.4% chance that it would be larger than it would be acceptable. It does seem like I may have, instead of doing the target weight plus mu, I did the target weight at the target minus mu. I don't know how I would do it, but like once I find the quantile area, I have some number like 1.25, right? Or 0.799. What I did was I created two equations. One with the quantile of A and one with the quantile of B, and I was able to find the standard deviation. But I don't know how I would be able to find the mean volume. Or I may have inversed the mean volume, because now that I'm looking at, hey, what's the probability that A is larger than 377? It's the inverse of that, which is weird. So I may have found the mean the opposite way. What do you think? But when I'm writing my workout, I want it to flow. I don't really get why I added. Let's start with the way I would solve it. I'd start so that it's clear in my head. I'd start with the acceptable weight, which is larger than 377, right? And so my quantile, when I'm writing it on paper, would I write quantile A2 minus mu over standard deviation, comma 0.8944 is equals to some value, and that value is the target minus our mu over lambda, over standard deviation, or is it like that's what I was talking about. And then for quantile of like B, I know that the mean has to be like 2.7 less, so that's also what I wrote. Target weight minus mean minus 2.7, or is that the other way around? Then what I was able to do was I was able to find kind of like two equations, and that's how I was able to solve for standard deviation. But I mixed up the sign. Instead of doing mu is equals to 300 plus the 1.25027 something standard deviation, I went minus. So that might be a problem with the way I'm interpreting the question. That's fucking up with the sign. So you gotta tell me about it. Hello. Hi. Hi. I love you. I'm gonna study. Okay. Okay. I love you. I'll meet. Thank you for calling me. Càng ngày càng gù lưng chứ không cao được đâu, thế nên là học toán suốt ngày. Nhưng mà trên có conviction, trên trên muốn làm giàu nên là trên sẽ học toán. Trên biết toán rất là tốt luôn. Lý do gù lưng là tại vì top 10 những người giàu nhất thế giới ai cũng có một cái bằng toán hết. Và nó đến từ chắc là lối suy nghĩ hả? Lối suy nghĩ của họ về thế giới nó sẽ rất là toán. Vậy ạ. Do I give up not being tall? No, I do want to be tall always. Just that I just gotta stretch in between. You know what I mean? One sec. One sec. Yeah, let me show you. So cái hôm trước á là lúc mà trên đặt ấy, là trên đặt cái này. Tại vì khi mà đặt cái của Christine, sorry, hơi bừa nha. That's your headphones and your guitar stand and the Lego set. Sorry, I just have a bunch of vitamins and monsters that I'm drinking, so. But yes, I can put you here now. I think you could use laptop. Yeah. I really want to get the highest possible grade in the whole school. And I think I could. If I'm being honest, cuối năm, if I keep guiding, then not a lot of students can beat me. I will never let another student beat me at something. So I want to win. I was born a winner. I'm going to be a winner. Let's clear this. Good luck, Christine. Maybe after econ we can go the Blue Mountains. Ở trong ngày, so it's okay. Target. If you have some time right now, could you search up Blue Mountains? I would want us to go hiking. We can go early and come home early. Đi nổi chứ, đi bộ thôi mà, đi bộ không phải chạy, không phải gì hết. Trên sợ quá. Christine, I think I'm gonna stick with math for the duration of my university life. But I think I'm gonna do statistics. So it's more about research and less about math tests. But it's really good. Math's good for me. Normal. 494.1. 5.1. One minus CDF. Sorry, this is A part. I hate stat. Yeah, stat is good. 0.8841670230. Huh? What happened? Is that right? Yep. Okay. Mean volume of more than so target is 300 and 488. Hmm. Um. No, I'm not happy with this. Just use the normal method. guess it works. It's okay. 人缘人小. Rolling tanks by salty water. Mixing problems. Three more questions here, and then fucking like 18 questions, bro. These two. Where do we go from here? Regrind, right? Regrind and review. The last few hours of the revision is the scariest. Tanganese contains 125 liters of water. Tank 1. But usually that's the concentration times volume, right? Or tank 2 contains 40 liters of water. 20 kilos of salt. The liquid in each tank is constantly stirred. Liquid is pumped from the first tank into the second with 3 liters a second. Second at a 7. To keep the volumes constant, pure water is added to the second tank. So pure water. And liquid is drained. Okay, so intuitively, long time means 0 salt. Okay? They're trying to find the differential equations to describe the amount of salt in each tank in future times. Right. To find the differential equation that describes the behavior of the system, they decide to calculate the change in Y1, which is the change in salt in tank 1 expressed in kilograms between times T plus delta T. So dt, T plus dt. Note the various factors contribute to the change in the amount of salt in tank 1. They decide to help you determine the change in the salt due to one of the factors. They suggest answering the following questions to begin with. Which of the following expressions is equal to the number of liters moving from 2 to 1 between time t and t plus dt? What is this dt supposed to mean? You know, it's going in at 7 liters a second. So would it not just be 7? I don't know. I choose 7. Oh shit. It's because I created a new set. It's because I created a new set. I have to delete these guys now. Stop. Oh no, I'd choose. Nine. That's my guess. Absolutely wrong. This means that we need the man ChatGPT to just explain. Start explaining, my man. Thrown off by the t plus delta t. Using step 1 or otherwise, determine the following expressions that best estimate the number of kilograms of salt moving from tank 1 to tank 2 between T and T whatever. So delta T is what? This is kilograms. Would you go to would you divide by the liters? Yes, you would divide by the liters. That's my assumption. So step 2. Number of kilogram of salt moving. So number of kilogram, not concentration. If 100 liters of water with 20 kilograms of salt, so that's 20 kilograms of salt and salt from T1 to T2, where T1 has 20 kilogram salt, T1 100-liter water, and T1 to T2 equals 9. Okay. Okay, I could live with that. So okay. They want to tell you to repeat those steps for other factors to evaluate contribution and change the amount. One of these contributions gives an expression by taking the limit of delta y change in salt over change in time as the next bit of time approaches 0, one finds an expression in terms of y1, y2. Why is there a plus minus 5? It would be minus 5. The change in y2 over time. dy2 over t. Change in salt in y2 is 5 liters coming in, uh, 9 liters of coming in, coming out. Okay. Ew. Ew. Okay. And okay, so we're setting up a system of equation. which is equals to PRQS. Eigenvector PRQS has that form. And they tell you that the solution to that equation is that. That's C something and n is -2. So n should be 1, no? Huh? They tell you that n is not equals to 2, so n is 1. And the expression for that where do they get these C values though? Are we doing some diff? We know that the eigenvector is equals to that. Okay, well, using what I already know. Where do those numbers come from is the only part where I have yet to see. Those are my lambdas and those are my C's. How do I find my C's? I find my C's by solving for lambda. I already have lambda. No, if he gives me that, then I'm happy. Oh. Oh. X is equal to some very, very nice cosine 2s squared ds. So s is the dummy variable, yt integrate t. Okay, very cool. This is an Euler spiral in the plane. The arc length of this curve we have two functions, right? Arc length. What would you do? You do like we'll check the math course. Okay, so I already see that when we differentiate, we'll by fundamental theorem of our calculus, right? minutes. So they want us to simplify this expression. Let's factor this one. $684 divided by 6 is what? 24, 6, fucking 114 or some shit? No. 100 and... 114 maybe. 684 divided by 6. Yep. Maybe 36 squared? What's 36 squared? Nope. 6 cubed. Nope. 6 cubed times 3. 3 times, okay. 3 times 6 cubed. Could that be something? I see a 4 on the outside. Or do you want me to... Oh, it's chill. X. This implies that x prime is 4 cosine 21. 6t sine 6t cosine. We'll do 6 cubed times 3t squared. Could we do anything else? 6 times 3 is, I don't know, 2 squared, 3 squared, 18. 6 times 3, 18. 3 cubed, maybe? Nope. Nope. Is it same equation? Nope. What can we factor out? If I square that shit, everything is squared, right? So this is equals to force, try. Let's just see what it looks like. Is that clean enough? I think that's clean enough. Yeah, it's not too ugly. Nice. Okay, so that's clean enough. Now suppose we want to evaluate these integrals. First step for this integral is what's an odd cosine. And when you evaluate odd cosines, it's ugly, right? So the integration technique would be to also this is even cosines and odd cosines. So odd cosine, even cos. The calc notes would say use u equals cos. This one would use combinations of something like that. Let me see. Integration techniques. One over cosine 2x. Yeah, that's fine. In the case where both m and n are even, it requires that. Yeah. Okay. Yeah. Shall we start with um this is some step there, right? We have this is something like that. U to the 38. One minus sine squared. Hmm. Yeah. Start with the recalls. Hmm. Integration. What did I do? Oh, should I have swapped it like this? Recall that this is that. Then we have that is that squared 24 times sine to 38. We let u is that, and then that's 1 minus, yeah. Is that not right? Recall that integral b, or second integral. Ugh. Both powers are even. You then expand into powers of cosine 2. Thus, therefore, replace your final card with oh, okay, not u substitutions. That's ugly. That's wrong. Like that. Okay. It's not okay. I made some mistakes, but that's my first try. It's not like I didn't understand what the fuck they were talking about. Okay. Each such integral has the form similar a to b, and these methods must be applied repeatedly. So I must be so in tune with every single other question that I get some time to basically attempt and get as many marks as I can for the unseen questions. So we don't want to use this one. Don't want to use this one. No substitutions. Okay, not bad. What are with these sick questions? 12. Consider the ordinary differential equation. Okay. First method or second method, which is separable or integration. I would start with a solution as a separable ODE or a first order linear ODE. And I would start with let's do separable. If you separate, you get dy over 2 start with this, right? Do you want me to do it like that? Yeah, exponentiate. I would divide. That was a good first step. That was like a second good step. Right? One, two, three, four. Okay. Nice. Oh. Okay. Not too bad. Not too bad. Was kind of trippy, but not too bad. Alright, so we're done with that. We're done with that. And we have number of unseen questions go down to 18 questions. We want to be able to finish all 18 questions so that we can grind past papers and review everything. I'll be living off of I feel awake, I feel alive, I feel strong, I feel powerful. I can go for more. Let's not break the momentum here. Let's go to T3. Đóng thêm 10 tiếng vào nữa. Ngủ 4 đến 5 tiếng. Xong rồi cày thêm 30 tiếng nữa trước khi đi thi là tác phẩm luôn, không thua được ai hết. Thật sự nếu mà có thêm 1 đến 2 ngày nữa thì đi thi ổn. Làm cái này hôm nay thì vui lắm này. May quá, không có nhiều. Oh. It's just a transformation, brother. Did he give me this question? No. It's the sum question. Every second counts. We're always trying to be struggling to doing the ones where it's like really, really, really tough. The core itself took how many hours? Like 4 to 5 hours to basically grind down. I don't want to do core anymore. I do want to do everything else. So I think we alternate. We do an exam and then we do some questions. And we do an exam, we do some questions, we do an exam, we do some unseen questions. Okay. 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 It's a equilateral triangle. So whatever the other one was scaled, I could just scale it, right? Because it was an equilateral triangle, do I know the area from that moment onwards? Is it going to be like cosine pi on 6 away with the same distance? Do we know the distance from this to this? 75 over 3 and 5. Let's just like, let's guesstimate. They say it's both on the whatever, so this is 7 on 5, 3 on 5. Let's guesstimate. Bunch of cosines and sines. We want to, well, we know this is about 1.4, 0.6. This is what? Eval 14 minus 5 times square root 3 on 10. 13. 13. 13.13. Wait, so this is 1.4, 0.6. This one has 0.1. So M should be somewhere here. Right. So the distance from there to there. Could we find the it's a linear transformation. So I know some wait, I can find it. A is equals to P times Q. Sorry. AP is equals to Q. A is equals to Q times P inverse. Right. We have A, we have Q. We want to find P. P is equals to input of the be K and L. Probably cleaner. Yeah, it's probably cleaner there. So that's equals to Q times inverse A. Alright, let's set this up. A is equals to is that how it's supposed to go? Yep. Also, we should recognize that that looks like a big ass cosine rotation. Right? That's the same as 1 over root 2, which is cosine pi on 4. Right? And they scale it up like 25 times. And that's half of pi on 4. Cosine pi on 4. If I had Milan Popor's notes, it would be pretty nice, but if I could remember or understand the notes, it would be even better. But we could find our way into some transformations. Right? Geometric transformations, maybe? Cosine transformations. Do we see any? Do you have a big table in here that has transformations? Would it be too easy, eh? Man, I wish I could use Milan Power's notes. That's okay. We're gonna use Q as that. It's basically XY, right? Seven on 5. 3 on 5. O in bracket 14 minus 5 times square root 3 over 10. 1 over 10. Okay. P should be defined as the input vectors. So input vector, input position vectors for KL. Oof. That doesn't look good. I think we have to move to sines and cosines, man. Cosine minus sine cos. Cosine minus sine cos. I should start using it so that I can. This is one of the most important pages for transformations. This is a hard question. Damn it. Is there any way to work with Maple so that I can convert these guys into like cosine functions? Like I could recognize that minus root 2 on 2 is minus 1 over root 2, which should be like something part of the unit circle, right? Like minus cosine pi on 4. Something of the latter. Or I should understand that the rotation anti-clockwise about the origin is cosine is with the matrix cosine theta, sine theta, minus sine theta, cosine theta. So I kind of want a way to like remember these guys because it's getting kind of hard to really remember them. If it's anti-clockwise, that goes in the direction of the unit circle, right? Which is using cosine, sine, minus sine, cosine. If it's clockwise, we're using we're adding minus sines, minus thetas to everything, and because cosine's even, it stays even. So the only change is basically the minus sign at the bottom, right? I should be remembering these. I should be knowing this, but intuitively the teachers don't teach this, and this just gets overcomplicated. Dilation. This is where I should be working on trig simplification approach. These are Maple notes. Trig. Combine. Rad. Rad simp. Rad simp. Nope. Combine. So we try to work with okay, they're working in rows. Oof. 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 To work in rows. No, this would be one of the easiest methods to learn. Alpha arctan. How would you walk a human through solving this equation? Because in most cases we won't be able to precisely remember most of the information, but I could make an effort to remember the column, right? So column E1 is cosine theta, sine theta. Column 2 is minus sine theta, cosine theta. So I could remember that for any related transformations, but that's basically kind of, if we are able to derive most information off of that, it'd be pretty nice. We do know the unit circle, which is also pretty nice. So as long as we have our perfect triangles and our unit circles, how could you teach me or walk me through this? Let's revise our perfect circles. So this is our first perfect circle. I have to remember this like every day, bro. Nhớ đi, nhớ trong đầu đi. Vẽ 1000 lần luôn đi để xài. Tại vì mày mà không biết xài thì mày chết luôn đấy. 30 nhớ 1. Chỉ nhớ cái 30 với 1 thôi là cái gì cũng nhớ được. Đúng không? 30, 60 nhớ 1 này, always commit to memory, bro. If we use it, we can commit to memory, but we don't use it enough. Okay. Use the unit circle. Right. Both magnitudes are pi 2 and 2, so the reference angle comes from the 45. This sign tells us that the quadrant cosine negative, left side, sine positive, upper side. Do we have a unit circle in math 1131? Nope. Do we have a unit circle here? Dude, unit circle was so many fucking... It was so long ago, bro. You're telling me to have perfect memory. if this question comes out, brother, cram it in my head. Okay, so yes, just rotate by 60. Okay, it's so much better. Okay, so I have the output, right? And then I'm going to find the distance between them. And then rotate. Are you saying rotate by using the matrix? Cosine pi on 3 and every other theta is pi on 3. Is that what you mean? Okay. Once again, we're route learning just to make has our Apple Pencil died? It has died. We want K image equals K image equals that 7 on 5, 3 on 5, and image of L is 14 minus 5 root 3 on 10 and 1 on 10. K minus L gives, sorry, L minus K. L minus K gives vector from K to L, right? So basically this here and this here. and I have this vector, then I'm going to either rotate by 60 degrees or by 60 degrees. And either way, I will form a triangle. So we start with, let's delete everything here. We'll do, so let's say we won't use this. We will do, K is this. MK. MK. ML is 14 minus 5 times square root 3 on 10. Yep. And 1 on 10. ML minus MK gives me that. Rotation matrix equals cos pi on 3 sine pi on 3 minus sine pi on 3 cosine pi on 3. Yep. And then with linear algebra, we'll call this, what? We'll call this KL. Matrix multiply rotation matrix with KL. We'll get that. I didn't get that. Okay, how about I use minus sign, minus sign, minus sign, minus sign. Okay, then I get some matrix. Try with either rotation clockwise or anti-clockwise. Then we get that matrix, which is nice. Then you want us to do K MK plus that gives me that. And then A is this. Then copy in A. Matrix multiply A times, so this is M. M. No? Why? Sorry, work backwards to T. Oh, that gives me image. That gives me image M. That gives me mm. We then need, right. Oh, it's okay. I could do this with the power of AI. So I think we start our step with, okay, it's still charging. We get LK gives a vector that gives me minus root 3 on 2 minus a half rotation, either plus 60 or minus 60 degrees, cosine pi on 3 sine pi on 3 minus sine pi on 3 cosine pi on 3. Okay, then we get m equals KL minus 3 pi on 2 half. Then K mk plus this m. Okay, then since m equals m equals image m times A inverse. M equals matrix multiply mm times matrix inverse A. Yeah. Do I know? Let's that ml minus mk have a rotation matrix, multiply the rotation matrix, create a new image for m, and then inverse define m. That's fine. So we know A is that, and we know CB is that, and we know that is equals to sum cosine A y plus B cosine A minus gamma sine alpha plus beta cosine alpha. So we start with this is cosine, this is sine. and alpha is okay. Could we do cosine alpha is equals to this find alpha? Let's see. Solve cosine x is equal 2 on 2 x. Yeah, okay. Substitute that cosine alpha, sine alpha. Okay. Comparing that plus that. Right. Let's see. Come on, start charging. Can I use you? Yes. Let's go. So cos alpha sine alpha. You've got cos alpha equals maple alpha equals 3 pi on 4. Okay? Is it B times C? Is that what they did? They did CB. Followed by a stretch. So rotation, then stretch. So must do stretch times rotation. Yep, it's fine. C times B Oh my god. Is that it? Oh, fuck. Minus sine A plus beta cos A is equals to minus... Is it minus sine? Okay. Minus sine A. Right. Right. Which is... Right. Right. This makes it 6 and divide by 2 makes this okay. Okay. Which is equals to this, this, and you cancel that out, so you've got this is this. Okay. Okay, I've got both equations. Are we solving for them both? Wow, that was a pain in the ass to solve, by the way. Yep. The question is, could I do this in the exam? If we took our time, the only hard part would be the KLM part. Okay. Seven, 3, 6. Okay. Gotta move through these guys a little bit faster. It's taking some time because this 2024 one is taking quite a while. Yeah, these are one of the harder questions for math. Did they just give me the values? GG's, bro. Honestly, purely GG's. I just like say Q1 here. Hard. And we solve it like last minute or some shit. We got enough marks to go around. That would give me 4.2 marks. That would give me 4.2 marks. I could do that. This question concerns the eigenvalues of the general 2-on-2 matrix. Recall that A has trace and determinant given by trace A, which is equals to A plus D, and determinant A, which is AD minus BC, respectively. Complete the following passage by text by selecting the correct option from each list. The eigenvalues. Ooh, I've never learned about trace. Barely mentioned. Yeah, it's okay. We don't need to get that 0.8 steps. 0.8 marks. We just need the other. We just need the first couple of marks. Let's do part A first. For an eigenvalue lambda, we need determinant A minus that is equals to 0. And so we have... So are we using their definition? Kind of following their playbook? You start with a vector, with a matrix A, B, C, D. And you compute the determinant. Oh, sorry, the characteristic polynomial. Is that right? And you set equals 0, which gives us... It's okay. I'll just learn it. Doesn't matter. Let's do these bad boys first. Lambda squared minus A lambda minus D lambda plus AD. minus BC. So see that this is there and this value. Okay. Okay. Minus trace A plus determine the condition to have two real eigenvalues. Determinant must larger than 0. So B is minus trace. Would B be minus trace A? Yes. A is 1. C is det A. So minus trace A squared. Sorry, that's right. Determinant is minus trace A squared minus 4 times 1 times det A. Has to be larger or equal to, has to be larger, strictly larger than 0. Which is basically minus b squared. Well, is it minus b? A b squared. B squared. B squared. Sure. Sure. That works. So 1 over 4 times the trace is going to be larger than the determinant. If we assume that it has two realistic values and eigen is less than 0, then if that's smaller than 0, that's larger than 0. And how big is A? Well, it's probably bigger than that. Fuck. A mass for that is smaller than A. AC method. Okay. Recall by AC method. Recall by AC method that roots of quadratic are lambda 1, lambda 2, and if question assumes that a is less than 0, then a lambda is negative and a lambda is positive. Okay. Therefore, we have lambda 1 is less than 0 is smaller than lambda 2. Okay. Show me how to derive this. Can you show me how to derive this, actually? I can't see the inequality yet. If you show me the inequality, I'll be able to see it. I don't have the vision for it yet. lambda is equals to 0 is an eigenvalue if and only if the kernel isn't equals to 0, which also means the determinant is equals to 0. So test the statement. We calculate the determinant and det A is equals to A times, so that's D. What's D? Okay, so they're saying suppose A has the matrix A, B, C, and BC on A. Then det Okay. I'm just trying to blast through these guys because these guys are taking a while. What's this next one? Okay. 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 I don't like to live with regret, so I will do all of these questions, whatever is necessary, so that we can at least be relatively confident that we will go into the exam having been exposed to most questions. Core, I won't practice at all. Practice the rest. Core is like simple enough where chances are we only practice like the last 2 or 3. Come on. I go pee, and then I down another bottle of Actually, no, we do want a productive day tomorrow, so I might not want to down it. Yeah. I would be losing steam in a little bit. I don't want tomorrow to be a day full of 2024 papers. So I'd really love if we could like tackle the next 3 questions in the next hour, and then the 12 questions like we can start to do really quickly. What is this? Start with an eigenvector. Oh, sick. Okay. Sorry? Two times COD. Hmm. Both eigenvalues are there for a half. Dude, what the Right. Sure, I guess I could do it. I mean, if I can commit to a short-term memory, I can pattern recognize and route learn. In most instances, these would need to be route learnable. I don't think I would learn them. These I understand. Set A is equals to whatever is needed. If this is that, that doesn't work. If kernel is that, nullity is 1. If nullity is equals 0, lambda can't be equals to 0. We gotta have a positive negative value. Trace is pretty sick. Set that equation. I'll set the determinant to have two really distinct values. And this is assuming that it has, assuming the determinant is less than 0. Try to like draw it back into this equation. Sure. This one is using the idea of trace, but starting with 1, 1, multiplying 1, 1 in, simplifying, seeing that lambda is half, and then finding a first condition for C and D. After you find first condition for C and D, notice that A plus D is equals to trace, and A plus D is that plus that should equals to the trace. And the trace is what? I don't know what the fuck the multiplicity 2 means. Sum of eigenvalues equals trace. That's what I need to know. Is that why? Sum of roots equals trace. Product of roots equals AC. Wait. So the sum of the roots equals the trace, and the product of the roots equals the... What is the product of the roots equal? I just need to know that the sum of the roots equals the trace. Use the idea that the sum of the roots equals the trace. Okay, product equals determinant. Okay. Sum of roots is trace, determinant. Product of roots is determinant. Okay. Make nullity not equal 0 or vector is equal something. Sum of roots equals trace to help find conditions for D and C. 1, 2, 3, 4. 4 more. Before our other fucking questions. I'm gonna go take a poop.